is up, party people? I'm not even going to say sorry for the late start, because, hey, it's how I roll. I don't even know why I should just start a half hour later than I want to start, and then that way I'll be on time. But then it'd be odd, because then everyone would be like, why is he on time? Doesn't make... Oh, confused. Yeah, see? That's why. So, one of the things I wanted to say right off the bat before we get into this topic discussion, I want to say a big fuck you to Ali B, who I have now put in my line of sights for questioning on whether or not he's a true believer of flat Earth or a troll. I don't know what the fuck Ali's problem is, what he watched to make the opinion that he made, but Ali decided to ban me from his channel and talk a lot of shit based on what happened with Travis. And I just wanted to say right now, maybe you should rewatch the times Travis was here, Ali, and you can see how disingenuous he really is, because he's catching up to you. So with that said, I'm gonna go ahead and ignore the fucking rest of that part because he's a bitch. Anyway, let's say what's up to everybody. Hey, what's up, Amy? Thank you for being here. What's up, Sean? How you doing, sir? What's up, Grizz? It's a long time no see. Soul, how you doing? Jason, the only concaver to exist. What's up, B-Ball? What's up, RT? They and them, what's up? What's up, M Stone? No name, how you doing, sir? I have 2 videos premiering at the same time. Do I really? I had no clue. Let me see. I do randomly do stupid shit like that all the time. I think my last one was actually going. Let's see what you mean there, buddy. I do know that I got taken down already. Oh shit, I do. Let me see something. I'm wondering if I'm even on the one I want it to be. Yep, I'm on the right one. Alright, let me go ahead and take the other one down because I don't know why the fuck that's there. But I do know this stream that we're on right now, it's already been the monetization's already been taken off. Guess I shouldn't have started that cussing with about Ali already, huh? Oh well. Alright, yeah, I did. Let me go ahead and it's taken care of, so now hopefully you guys won't see that. Here we go. So, who else is here? What's up, G Hammer? What's up, Aaron? How you doing, sir? I think GPS, how you doing? And Zombie Wolf, how you doing? I think that's it. If I missed your name, I do apologize. It was actually a long list that sucks ass having to watch. Well, what's up, Chunky? How you doing? It's been a while. What's up, Monkey? Okay, so now that we're done with that, what's up, Digital? Let's get into the topic at hand that I wanted to talk about. I will open up the panel. What I wanted to do is kind of give you guys a good idea of what I was talking about in the description so that it makes more sense, and that would be this. So this whole model talk, it's odd. I don't even know why we're even having where's your model talk, because again, models isn't Earth. Models aren't everything that is encrypted into what Earth is. It's literally data that's been observed, collected, and recorded, put onto a visualization of Earth. I mean, let's look at exactly what I'm talking about. This is a pretty damn good site. I've only been on here today, so I'm still learning how everything works, but here's a link so everyone knows what I'm talking about on your own time. Yeah, so basically, again, a model is only a projection of the data that was obtained. There's nothing more, nothing less. Here's the issue for flat Earth. These models with the data would have to then fit on a flat Earth theory, which would then create a model. It's pretty simple on how that works. For the most part, these models don't prove Earth is a globe either. What they do is they show the data that was collected. That's it. That's it. Nothing more, nothing less. It's not like this real thing that everyone should be able to walk outside and go see like it's depicted as. If you want to look at a model that would be, for instance, so the one we're looking at right now is depicting, I didn't even pick this one, so let me go ahead and get one I can actually work with. Okay, here we go. Oh, I didn't even see this, but I guess that would destroy all that flat earth argument. There goes variables, so we can change those up pretty good. That's nice. Like I said, I just got on this one, so I'm trying to figure out where I would go to find out. Okay, here we go. So this model, this is a geological model, basically showing the geology of Earth, whether it be the depth, whether it be different locations. For instance, this one is a depth model. So what it's doing is showing us in that area what the depth and the terrain and the types of sediment that are there. It'd take me a lot longer to just actually get into this, so I wanted to show it to you guys, but I can show you one that I know everything about. So another model that we would use, and we do use on a regular basis, is I forgot what I was gonna say. I just lost track of mine reading the chat. My bad. First, this is a topo map. I've already explained to you guys that I do topos and all that stuff. This is what I do for a living when I'm starting projects. But more importantly, this isn't going to be something that you would use to find out how deep the ocean, or exactly what you would use, or how much forest is in the area, how much water is in the area. Isn't a model you're going to use to find out curvature. Why? Because it's not trying to. The data that was put into this work wasn't measuring curvature. It was measuring the topography of the land. It's not going to show you these random situations of where's the water at? Where is this at? No. Sorry guys, it just doesn't do it. It's not how it works. Again, like I said, this whole model talk to me is ridiculous. We should not be having the talk of model. I've said this 1,000 times. A model is data that was recorded and then put onto a visualization so that therefore you can be able to go about it. Go ahead and use this one first. So this is a projection or a model of topo model of my local mountains. And we'll kind of go from there. Like I said, and also, you know how guys roll. We don't have to talk about this the whole time if you don't want to, but I do plan on talking about this right now because it does play into a lot of what Flat Earth believes is going on and how we know if it is or not that way. Gotta put it in the background, see if it'll work. There we go. I know what I did wrong. Okay, so what we're just looking at is the terrain model. Now we're going to look at the topo. For those of you who don't know what a topo is, it's basically the topography of the land, elevations, and how it flows, basically. I'll go into it right now. And while I do that, I'll also put the link in the chat. All right, I did for you guys. My bad, I forgot. All right, so like I said, it's the topography of the land. What you guys are looking at now is a pretty rough example of it. What you're seeing right now is the topography, obviously, roads, different areas, but now we'll kind of we'll zoom in a little bit. Then what we'll start seeing, oh no, way too much. I hate this damn map. Let's use this. We're gonna go ahead and use this one. This one's much better. Where is it? Google Earth Pro. There we go. Bam. What is up, Aaron? How you doing, sir?
What's up, Tom?
How you been? I said, how are you? Man, I said, how you been? That's where you go fine.
You talking to me? I thought you said,
Yeah.
hey, Glenn.
No, I said, hey man, how you doing?
Oh, I'm
I
alright,
don't
I'm
even
alright. Well,
know a Glenn.
I see. You said, how you been? I thought you said, go, Glenn, or some
Oh.
shit.
Actually, you may actually enjoy this stream. I'm gonna start right now. Well, right now at least, I'm gonna start going over the topos and stuff and how I make them. I'm not gonna show how I make them, but basically what they are and how they work. Like I said,
Yeah,
there's a
I'd be the guy on the other end using your topos. That's what I'd
yes,
be doing.
hmm
Yeah.
and so yeah, so you see it. Okay, everyone can see it. So basically, what I wanted to show is this because, like I said, when the reason I started doing this or this concept of what we're talking about is this right here. If you guys remember, you guys love when I say this is the Anacapa Islands from our wonderful Travis experience. Like I said, I decided I'm going to make a topo map. I'm going to show you guys basically step for step how it's done. Let's see. Okay, cool. So basically, this is a very crude version of it, how it's done. But one of the reasons I did this is because knowing how topography works, for instance, at I think Travis was 21 miles away at the time, it gives you an idea of what you're looking at, really looking at. When Erebus showed the overlay of the boat, the obstruction, and then the actual land behind it, it overlaid so you can see what's missing. That was pretty much the point where Flat Earth said it was bullshit, and that's very disingenuous. I really pisses me off that happened, and the reason for that, I got feedback in my camera. You guys hear things in the background? Let me know if you hear background sounds, because for some reason my audio is jumping. Hang on, let's make sure. Nope, no, I don't see anything. No, nope, nothing. Okay, so like I said, the idea that if you knew what you were looking at from those distances, it'd be easier. So in this situation, the first thing I did at least was I went to the topo map. I haven't got one up yet, but what I do have is this awesome fucking software that will let me use this. All right, let me see if that will work. There it is, perfect. So what I pulled up is it's basically a software that goes for Google Earth, but what it does is it allows you to use it as a topography map. We'll go ahead and click on it so we can see a little bit better. Then let me see where I gotta go now. Okay, I see. Damn. All right, wait for it to pop up on my other screen, guys. There we go. Yeah, it's so no name. Do you still hear it right now? Because Aaron muted himself, so and I stopped hearing it. So I'm not sure if that was what you were hearing or not.
Yeah, I muted.
Yeah, thank you, sir. It was definitely it's on my end. It was coming from Aaron, but anyway. So basically, now what we're looking at is a actual topo map. This is a very great topo map to be exact. Let me go to a clear area so that way we can show you something else. Oh no, I'm crashing. Hang on. There we go. Hang on, it's not responding. I don't know if you guys can see that or not. All right, there we go. So, for instance, oh, that's actually a perfect spot where we'll use. So right here, for instance, on the coast, see those lines? Those lines are depicting the shelf. Not sure if you guys, how much experience you guys have in this, but Dave asked me on the topo, what is the elevation based on? For this, for instance, on this one, this would be based on a geodetic point. So basically, a survey crew came out, and from what mean sea level would be their zero. So from that and their data that they have collected, most likely using GPS, would then start working their way offshore, basically. Where one is, I actually do know where one is. Hang on. I got to figure out this map and it'll work a little bit better. In the meantime, Aaron, have you broke ground on projects yet?
Yeah, absolutely.
Okay, so when you break ground and you have your surveyors, the surveyors, you obviously know, would be working off this and a projected idea of what, where everything's going to be, right?
I don't know if they're working off of that, but I can assume, yeah. But
Well,
yeah, I don't.
yeah.
I'm not in the office. You know what I mean? I'm not.
Yeah. Okay. Yeah. Well, basically, for anyone who doesn't know, if you were to look at a set of blueprints, your blueprints would basically look like this, minus all the wording and the
Oh yeah.
yeah.
We have existing elevation contours.
Yes, exactly.
Definitely. Yeah.
Yeah. So when and I say we, I'm talking actually me and Aaron, we're looking at our plans or looking at survey stakes. A survey stake is basically what tells the construction companies what to do and where to do it. We're working off of this and then the projections of where we want to be. Trying to find a clear area so that way when we do look at this, it's not like a clusterfuck of what am I looking at. But more importantly, what I was trying to find is my local geodetic spot. Because I have a point, there's a geodetic point, but I got to find it first. In fact, I'll do it like this because I can find it so much easier like this. Okay, so the geodetic spot that I know they would have probably used, and again, it doesn't need to be used and have to be right next to where they are. I mean, it's like I said, GPS and all the other stuff will allow all this to be done with GPS now. So much better, it's so much easier. I'm trying to find a road. Where is it? Pine Valley. Sunset. Yep, there you go. The closest geodetic site I know of is... Where is it? Midpoint. Yes. So, right here. Right in that circle, there's a geodetic point. You guys obviously don't know exactly what it looks like, but I'm going to go ahead and pull it up for you so you know what we're looking at. Like I said, I've been to this spot before, so I know there's a geodetic point there. First, so we are looking at... How come you're not all talkative today?
Not yet.
You must have just got home from work.
I did, and the fucking weather just changed over here in Texas, South Texas. It's gonna be freezing tonight. It's fucking raining and shit. It's all fucked up.
Where are you at? Where are you at in Texas?
Northeast, about an hour north of Dallas.
Oh, okay. Okay. Yeah, because I know like San Antonio. I know San Antonio's. It's raining pretty good right now.
Yeah, it's all a whole bunch of shit coming in. But as you're talking, I'm just thinking about large cuts and fills that I've been on jobs, and definitely the surveyors will come in first and establish property lines, right?
Yes.
You don't
property lines, elevations, and then curb gutter, stuff like that. Yeah.
Clearing limits, just all the red tape government bullshit. You know?
Basically everything the construction company would need to know about the cuts and fills is what a surveyor is going to pinpoint for them.
Yeah, and we'd have, let's say, a 40-foot cut taken off the top of a hillside, and so we don't start out with stakes that say cut of 40 foot. You know.
No.
They actually set up a benchmark or
Yes.
more. You know,
Yes.
one or more all around the site, just for reference as you're massing it out. You know what I mean? So.
Yeah. Exporting, moving. I call it R&R, basically.
Yeah. What does R&R stand for you?
It's just restore. It's like restore of sediment. It's not
Oh,
actual. Not
reclaim and
actual.
restore, maybe, or
No. It's restore of sediment basically. So pull the dirt out, compact it in water.
I see.
Basically,
Yep,
just
yep, yep.
recompacting. It's a term basically we use here. Basically, when a contractor or import has come in and they fucked up and didn't do it right, so then you go back in and do an R&R.
Yep. Yep. Gotcha. Yeah, and so we, of course, we do strip cuts. You know what that means?
Yes.
Where you just start at one side or one place on the job and just
And you
move your
flop
way
it.
across.
Yeah, you just flop it around. Yeah. I don't know where it
Now,
is.
but we'd get within probably, let's just say, just to be safe, 3 or 4 foot of the benchmark and have you guys come back in and resurvey general, just
Yeah,
general,
yeah.
not, yeah,
All
just
right,
to make
perfect.
sure that we know main points.
I found it, people. So the geodetic point that's at this location is. I don't even know if you guys are going to see it. I got to open it up with something else. God damn it. God damn it. What's up, Sean? How you doing, sir?
Doing all right. How about yourself?
Doing pretty damn good. Pretty damn good. Just wanted to actually. That was the weird thing. When I got up, I was like, I don't even know if I'm gonna go live today because I woke up not feeling too well. And then the second I did decide I was gonna go live, it was like, hey, you know what you never talked about? The models and projections and stuff. Because let's keep it real. I mean, for the most part, well, flat Earth doesn't. I don't think they understand why it doesn't work the way they think it works. Right. I think this one is it. I can't stand this. Oh, my pictures aren't showing. Hang on. I got a display screen. That's what it is. There you guys go. Now you'll be able to see it.
Yeah, I
That
think
breaking up?
it gets to the point where they confuse a model, confuse models. They think that we want like a little two-dimensional something or another, but we want something that kind of proves what they are stating. You know, something that shows the sun, the moon, and the precession.
Yeah. And to do so, you're then having to use the data that you're collected, which is where you're probably gonna not. That's probably where you're gonna hit a brick wall when it comes to flat Earth information.
You mean that dreaded word map?
Yep, that's the one. The one that actually does prove
No.
what's being depicted. Oh, and for the other thing, Gleam, I would like you to come up here because yesterday you made some statements kind of I didn't like. Sorry about that. Not that I didn't like you or anything. It's just you made some statements upon these projected models and how things are recorded, basically. And one of the main reasons that I did want to do this stream is the projections of that like NASA have. You know, the flat Earth projections and all that kind of stuff for simulators. So in a second, I'll get into that. But we'll finish up what we're doing right now, so we don't, or I don't, forget and go on a different tangent. So, like I said, this is what we're looking at right now is a one of those geodetic points that people have been talking about, where they basically pinpoint a location and that becomes basically a data store. Okay, done with this one. Like I was saying, that is where this is. I can actually do that here, and I'll do it this way. Watch this. Don't worry, guys. As time goes, I will get better at this. I'm still learning the Google Earth, but I like it though. It's
Looks like
fun.
looks like a launch pad.
It's actually a helicopter pad.
Oh, okay. I thought you said it was geodetic discs. I've seen them before, older ones.
Mhm.
They're known. they're a known location. You can go hiking up in the mountains or
Yes.
wherever hills, and at least the Pacific Northwest is where I grew up. So, and you'll just be climbing up Mount Si, and if you are looking for it or you know what you're looking for, you can find it.
Oh yeah.
Which is pretty cool. And it's just this um, disc. It looks like a disc with a long ass rod that goes down in the ground to minimize movement, and so they're pretty cool to see. Who just thinking about the old dudes that fucking put those in there, or
Yeah.
chicks.
Way back when.
Yeah, didn't they have they used to be like triangles. Used to be like little triangles back in the day too, with
Um.
like a little round cap on the top. But they were more like for property markers, but they were still using them as points for designation,
Yeah.
leading back into larger properties.
Yeah. I'm trying to find. I have a whole thing of different geodetic points. I'm trying to find the rest of them. I can show you guys because they're different ideas. So like you were just saying how the older versions and everything. Um, I'm about to show you guys two versions of it. I think you saw probably one of them just now. Um, One of my favorite ones is this. Hang on, I'm trying to find the right one. Yeah, we'll use this because I've also said it before where they use for the most part they use GPS now. So a lot of like these points right here are placed after they've already done it. This is basically what it. Yep. Okay, so this is. You guys can't see it, can you? You guys are looking at what? I'm not
A
looking at
pink and green screen.
I see the helicopter pad.
Okay. Hang on, give me a second, because
I mean GPS pad. I'm sorry, my fault.
I have it on. That's weird. It's not letting me share my picture. Okay, there we go.
You were choppy a minute ago, or at least I don't know if that was on my end or your end, but maybe you have an
No,
internet
because what's
chip.
happening is that I'm trying to share. Um, it's better if I share. I have to share with you guys so you guys can see what you're looking at, but it's easier for me to share here with you guys, but then share on my OBS as well, so that way I can get a really big picture of what we're looking at. Because you can't really tell as good as you guys can here. So this is what we're looking at. This one is a GPS plot. So what a plane does is basically we'll just run the grid. Oh, I can't do it. Okay, so do that. So this is literally what GPS plot would look like, or site. When you get an area that is so large that you're not going to go send a survey crew out there to walk the whole damn thing, what's going to end up happening is they're going to want to do these GPS projections. And in my opinion, I think they're awesome. Basically, they'll do little zigzags, and if you guys can see these little red dots right there, that one. That would be basically the same thing as those geodetic points we were just looking at, but from a plane. So we saw this one, which is concave. Got this one, looks like a little mound. These are all geodetic points. This one is exactly what I think Dave in the chat was asking me about. He asked me how do the surveyors know where the elevation is and from what? This is a official. This is one of the ones they will use on the West Coast, I would say. This is what the USGS does, and any other surveying company, if they had to tally off a spot, this is what they would tally off of. One that says this, where it says the U.S. Coast and Geodetic Survey. This is the official one. Like I said, I don't think this one is as official. I think this one was done. I don't even remember the year. Oh, it's right there, 88. But you can find all these. So this one, all right, cool. So if you guys type in geodetic point 1988 NASA BFEC, you'll find that point. Same with these ones. I don't know if this one even says anything. This one's a little rustic. Yeah, it's a point where they would just use it. But yeah, those are geodetic points. That's how they would come off. What they would go off of, Dave, to find out where something 100 miles elevation is, instead of just guessing. Or for those flat earthers that want to say differently, they don't just GPS and trust that that's the elevation. But yeah, that's kind of one of the things I wanted to show you guys. There's a lot more I got to show you, so don't think there isn't. Let me see. I want to take that screen off. My bad, guys. I'm kind of just trying to get all this to make sense. There it goes. Oh, you can't see it. This, I wanted to show you guys this, but I'll show it to you later. Actually, I'll show you guys, and then everyone else can watch it, can see it on the screen, because it's not that big of a deal. So this is one of the older, but remade, I guess you would say, geodetics points. And they do this a lot, where they'll just kind of like, well, they're doing it now, where they're kind of like just putting them in there so you don't really notice them. But that one's along a walk path. It's actually quite small, not that large. But yeah, this is another one that they would have used. Actually, that one was in, I don't know if that's the number or the when it was made, but yeah, fun stuff. Do you guys take it off? When you're hearing this idea of we need models, or we want a flat Earth model, do you expect to get a flat Earth model ever, or do you understand that there's not going to be a model? I mean, they don't have data. That's the issue.
I just expect data of some sort that shows how things process in the sky, and kind of describe some of the things that we see. Like tides and stuff like that.
Exactly. Yeah. I actually do have more map. I'm trying to get these other projections up that I have. I was looking for a much easier. I know there's ones that are so easy to do and to break apart, but the problem was that I couldn't get them to show up on my OBS. It's a pain in the fucking ass doing it. Yeah, it's almost in my, so when this topic comes up, and I've had to deal with it a few times, of a model, I've said, do you understand what a model is? Very important. If you don't understand what a model is, we're almost wasting our time even having the conversation. What I wanted to show, and I can't figure out why it's not showing it.
Lunar excursion model. Oh, that's module. I'm sorry, Sean.
You're reading my shit? That's good. Let me see. I don't like this one. It's not going to work. I'll just type in. I'm just going to find a very simple one. Then we'll go off of there. And I'll share it with you guys right now so you guys can see what I'm talking about. Hey, what's up, Crash? How you doing, sir? Okay, so what we are going to be looking for are Earth models. I hate when they do that, but fine for now. For instance, this is actually perfect. This, in all its representation, oh, where'd it go? This, what you got, the big one? That is a model, Earth model. Doesn't need to be perfect. Doesn't need to be scale. It just literally needs to show us what the data says. That's it. I mean, there's no other discussion about it, really.
I could cut open an orange and it would look the same, right?
No. Well, you don't. wouldn't cut up an orange, it would look the same. Because no, if you eat an orange that looks like this, Aaron, it would explain a lot.
Okay, color. Besides colors, right?
Mhm.
Colors are, they add the colors to reinforce what we've seen before. But I mean, okay, I'm not going to argue with you right now.
Well, I mean,
Later.
what makes this any less of a model than anything else?
But you're saying it's a model of where I'm standing here talking to you. It's a model of
No,
that.
no, nope,
But
nope, nope. That is a model of the sediment and the sediment layers in the layers inside Earth. That has nothing to do with where you live. Has nothing to do with what road you're on. It has nothing to do with how many forests there are, where the ocean. None of that. It only is showing
okay,
what is
what's looking
the
at that?
huh?
You said that some of these are models of Earth, but I wasn't
Mhm.
looking at the exact picture you're looking at. Okay, yeah, that one. It looks like a gobstopper, dude.
Yeah, it looks pretty good. It looks edible. Maybe it looks kind of Play-Doh-ish now that I'm looking at it, but in all sense, it is a model. It's a functioning model. That's data was taken.
I don't know about functioning, right?
Yeah,
You're
yeah,
using
yeah, yeah. That wasn't a good word to use.
pretty tight terms.
It is a
Let's say it's an elementary representation model of what has been
okay. But are we talking about what
information
it's?
that has been given.
But are we
So,
talking about what it's made out of, or are we talking about what data has been collected and then visually being shown to us now? Because
yeah, an elementary
because
representation of
this
information
model,
that has been collected.
yeah,
Let's say.
this model does the same thing this model does. That'll be better because it actually shows us same thing.
What do they? But what do they do? You said that they do the same thing.
Yeah, they're showing us the different crust, the crust, mantle, uh, the atmosphere, upper mantle, lower mantle, outer core, inner core. That is what the model is
Sure,
showing us. It's showing us
they represent each other.
no, it's
That's
showing us
about it.
showing us the layers of Earth.
Uh,
Both of
I have
them.
a model. I have a model of an F-14, and I could take that and compare it to a real one,
Yep.
and my model cannot do. It's not even close to the real thing. Not even close,
Are you well?
right? Except maybe the
Wait.
colors, and the stickers I
So what
put
you're
on
saying,
it.
but what you're saying isn't correct. So if you go to the store and you buy an F-14 Tomcat model and you build that
Hmm.
model as it says, and then you go to a air base and put that model next to that, yes, it is a model. That's why it is a model.
Okay, but I cannot time.
How well you assemble that model is on you.
I
Regardless, it's
cannot
still a
see
model.
it. I cannot see inside the fuselage. I cannot crawl into the cockpit of the real one. I cannot. There's so much information missing from my vision when I see the real one. When I look at my model,
Like what?
there's 99.9% of the information is missing. All I know is that mine is smaller, but it's the
That's
same
called
color.
that's scale.
Right? If I throw mine in the
Yep.
air, mine doesn't fly. Right?
Well, there are models that are 1/16 scale
Hmm.
that do go into that detail. But the overall thing is that you could take that into a pilot and he would say that's an F-16.
Well, he'd say it's a model of an F-16. Yeah, he would not say that that's the jet that he flies.
So it would be a model, right?
Just a model, yes, which is missing a shitload of information about the real
So Aaron, where's your model?
model of what?
Well, there's one of Earth here. Where's your model?
Well, what we're talking about, Sean, is that model that these models that Sean is showing are missing almost all of the information of the real thing.
What information?
Yes, the purpose of an illustrative model is to indicate the topic that you are kind of exploring, what we have figured out by now, the things that coincide with reality. If you're talking about that F-16 model, one example of where it would be accurate is when you put all the pieces on it, everything that protrudes from its surface and everything that takes up space in it, you can use it to measure aerodynamics. You can see where turbulence will occur, and we actually use models of airplanes to test their aerodynamic properties. Another thing that you could do is if your model is accurate enough, you can check where the center of gravity of that plane is, what point it will turn about, what's its stability, right? You can use it to test its free fall properties. In which position will it stabilize when it falls? Stuff like that. Now you cannot model an engine on basically a plastic model, and
Right.
those models that you buy in the store are models for visual representation. They are primarily made to, on the outside, look like that thing that you're building.
That's not,
However,
I don't
you will
agree with that.
also have model engines, which are fully functional engines, and you can use them to test and scale. You
Well-
need to know which things scale which way, but
Well, yeah.
Barney, a
But for,
functioning jet
hang on.
engine,
For
regardless.
instance, what I have up on the screen right now, that one is the real, and the other one is a model. Why couldn't the model be used for what you were saying, like the aerodynamics and stuff? It'd just be upon scale, right?
Well, that could, if I could respond to Barney, the aerodynamic test on that is only providing like 1% of the information of the real jet in
No, wait.
let's say aerobatic maneuvers. You can't do that in the wind tunnel,
Yes, you
right?
can. Yes,
Yeah,
you can.
just
Because all you
Yes,
do
you
is
can.
all you do is
Well,
tilt the
so
model
where's the
into a
thrust?
certain.
Where's the thrust on the model, Sean? Where's the
What,
thrust provided on the
so
model?
you put air
for
over it.
for aerodynamic properties, all that is relevant is its shape. If its shape is accurate and to scale, then you will have all the protrusions and you will be able to measure turbulence. You will be able to angle it against your flow of air and see under which conditions and which wind speeds do you get which kind of vorticity.
Can jets apply power to overcome certain aerodynamic problems that may occur on a modeled wind tunnel?
Yes, of course they can, and they can
Models can't do that, right?
apply drive-by-wire to compensate for things which no human can compensate quickly enough. The Eurofighter was actually deliberately made to be aerodynamically unstable.
Yeah.
Why? Because that enables it to turn incredibly quickly, because
Yeah.
it can just let go of its control, start spinning, and then regain control and basically catch itself in another orientation.
So in
Aaron,
the aerodynamic
Do you see,
model
Aaron? Do
setup,
you see what I'm playing right now?
uh, yeah,
Okay, that what they're doing right now is testing the aerodynamics of it. If one of those for instance, I'll show you right. Oh, that's perfect. If that hood isn't made correctly, they'll see that it's not aerodynamic, and will basically be fixed, and they'll adjust it. They do that with jets. That's why I was saying when you were saying, Barney, about that model we were showing. They could
Yeah,
use. I mean,
precisely.
they can use any model. I mean, like you. Okay, I see what you're saying. You were saying that model that I showed isn't going to be a model that they would use to show the engines, how the engines work, or something, right?
Yeah.
Okay.
aerodynamics is different than a wind tunnel test on a
No,
little Kia.
no, it's not.
Right?
no,
No, it's not.
Yes,
Because
it,
you can do the same thing if you have
no,
a
not at
model.
all.
If you have a
Yep.
model
yes.
that represents this car, you can do the same
Speeds,
test. It's just
temperatures. Come on.
everything. No, well, temperature. Why would you do temperatures on a model versus they're different materials? Anyway, this is for aerodynamics. It has nothing to do with temperature.
Right.
So
And
basically,
actually,
So
just
exactly.
that sentence that's on the screen right now
They're
Aaron, that
calculating the
sentence,
drag coefficient is all they're doing on that model right there.
What do you
that
think the
that
aerodynamics
sentence
is?
that's on the screen right now, where they take clay models from the stage to the vehicle shape, that's done in every car manufacturer. It's also done
No, we're
And
not
every
in
talking
plane
about.
manufacturer as
every
well.
plane manufacturer. Yep,
Or
exactly.
I don't know why I didn't. I can pull that up for you, Aaron, and it'll be easier for you.
And actually, they don't. They don't.
Now,
And Barney can correct me.
I agree
They
with
don't test
some of
the
what you're
whole.
saying.
Barney, real quick. Barney,
No
they
model
don't
is a
test the whole
complete and
airplane,
perfect
right?
representation of the object that it is modeling. Every
Isn't
model is made to test or explain one property or one type of property, one set of observations, one, right?
Barney, do they test fuselage shape on jets? Let's just say military jets, because they're most acrobatic, high speed. But don't they test wings
There's
and then
there's a wing
fuselage
right
and
here.
tail separately,
They do
and then put them together?
they do all
Possibly.
of
No,
it.
you test the airfoil you want to use, and then there. No, the entire airframe gets tested together.
Well,
Individual wing
hang
tests.
on, hang on. No,
No,
that's not
you
true.
do both.
That's not true.
You do
Look,
both
right
for
now,
different purposes.
yeah, right now we're looking at exactly that of the aircraft wing. But here's the thing: they're going to test the rigidity of the wing, and then
Right now, we're not looking at anything.
oh shit, I keep forgetting I'm not.
Thanks, Barney.
My bad, guys. I apologize. There we go. One more time.
There's no way to simulate a dogfight in a wind tunnel
Why
with
would
a
you?
model.
Why would you use a wind
Because the
tunnel for a
forces
dogfight?
involved there, the forces involved there.
Oh, okay. So I see what you're saying. So in this
Yeah.
situation, right here,
And that's
so
why we have test pilots, right? We have test pilots after that initial wind tunnel test is done and said, okay, well, the goddamn thing will fly.
no,
Let's
because
take it up.
they use these wind tunnels long before that plane ever
Yeah,
went
but
into
they're
the
not.
sky.
The test pilot is not using a model. He's not flying a model. He's actually flying.
Actually, I would say differently. I could see how when they start getting to the point where it does fly and they put it in a wind tunnel, I would say there are situations they probably do need a test pilot to actually create that situation. And in that situation, wouldn't the craft be a model because they know they're going to be
No, it's a real
projecting off of the
physical.
data?
No, it's physical. It's moving. And there's so much more data that needs to be collected that the model could not give. That's
Agreed.
why test pilots. Yeah.
Agreed. Yes, you need to test real life situations ultimately.
Extremities, of course.
Yes, but first you do all of those things through models and through localized tests and through localized explanations, right? You do rigidity tests on materials of certain length and certain profile. You do stress tests by bending it, and right, those are all model tests. If you didn't do those, that plane would never get to a phase where you could practically test it.
Matter of fact, I just
Now,
realized
Agreed.
it. You would use a simulator rather than a wind tunnel for anything to do with a dogfight.
ultimately,
These days, maybe, but even a simulator, Sean, is you tell a test pilot, hey, yo, we simulated this. Go out and pull a 7G turn, and then nose straight up and break back down and do all this crazy shit. You'll be all right? There are guys crazy enough to do that, and respect to them.
Well, that's why test
However-
pilots
Yep.
should get a lot more respect than they do.
However,
Yep. Actually,
However,
one of them
they're
was Joe
doing
Kittinger.
something-
He was a test
they're doing
pilot for
something
the
that
Air
was
Force for
only
years.
modeled on a computer. It was
Hey,
just
look,
modeled on a
You see what
computer.
you guys are working on right now?
A wind tunnel model.
Look, what is that? 737.
737. It's to scale. So everything you're looking at is in proportion to itself as the real one is. That's, I mean, the idea that a model is just some made up or just put together thing is not true at all. I mean,
Nobody said that, Sean.
They needed this. Oh, flat earthers do. No. Let me rephrase that. I say most globe and flat earthers have this same idea that you should just have a model, not realizing that it is only a depiction of the data that's been received. So the schematics for this plane, they built that off of this model off of that, and then they go put it in the wind tunnel. And after it's gone through the wind tunnel, they can see where the schematics, some of the schematics may have been wrong or not accurate enough.
Can I see in this video where they disable the right engine and only power that aircraft in this air tunnel on the right and left?
Why would they do that? They could do that.
Because that's going to be a real life scenario, and then do a barrel roll, and then do a barrel roll, and with an immediate climb, and then it dies. Right? You can't do that.
Yeah, because you're asking again. A model depicts a model. Hang on. And a model depicts the data that you're trying to get. So if you wanted to find out what happens if that wing falls off, and
no.
You said one engine,
I
right?
said disable the right engine.
So it doesn't work,
Just
right?
Disable the right engine.
Okay, you said disable.
No, you still have the left one. You still have the left one and the rear.
Get that. Okay, hang on.
Yes, Sean, don't use other illustrative examples next to his illustrative example. He has used a very specific illustrative example. You have to address that specific one and no other.
Okay, I apologize. So, in this situation, you know what? I know what you did there, and it's not going to work. Any situation that you need, you would obviously use your model or simulator in that situation, and then go off the data that you already have. Either way, no matter what, a model needs data to be made. That's the point.
My sister worked for Boeing, and I landed a 737 in San Francisco, actually, in a simulator. It was badass, actually, and just how real those things are pretty cool. It was a full size Boeing, elevated on hydraulic simulator.
Okay. Oh, so it had everything to do. Okay. So.
Oh yeah, it was nuts.
In that situation,
but that's how easy it is. Even a guy like me, can land a model.
Okay, I have a question. In that, while you were flying that simulator, did you feel inertia?
Oh yeah. It's felt like I was in an aircraft.
Okay. In that aircraft. So this is pretty much exactly why I wanted to do this topic. In that simulator, you felt all the forces that you would normally feel if you were in a plane.
Under normal conditions, calm conditions, coming into SFO to land.
Yeah, as long as the forces on you are less than 1G, you can do that in a simulator.
But they can ramp that up. I don't know if anybody else on the panel has been in an actual flight simulator, a real one. They'll make you crash, but they'll shut it off right before it gets too violent. You know what I mean? Because the hydraulics on it will shake. It'll make it feel all that
as
shit,
real as it can be. Yeah,
as it can.
And the best part is you just said
that's
exactly why. Yeah, here's the thing. You know all those NASA documents that keep coming out?
Simulator.
It's a model.
Yes, simulator.
It's a simulated model.
A simulator is a type of a model. The physics in it are not real physics. They are simulated physics.
A model doesn't move.
They are working off of a physics engine, which is a model.
A simulator simulates reality. A model doesn't move and doesn't simulate anything. You can just get data.
Actually, Aaron, models do move. That model that he was showing of that F-16, the cowl opened up, it moved. You could probably move the flaps as well.
I have a flying F-16 model and an F-15 in the garage.
Let me rephrase. Okay, if you have a remote controlled model, that's different than a static model.
No, wait, time out.
But it's the same thing as a simulator.
Sean showed pictures of a Play-Doh Earth and said this is a model of the crust
Yes,
layers and
there are
all that.
different models with
Okay. And what I
different
said, this
levels
is how the
of
conversation got
complexity and
started.
accuracy.
What I said was that model of Plato Earth with the crust layers and all this stuff, it is not exhibiting, it's missing almost 99% of the information of reality.
Every model is missing almost 99% of reality. Well,
That was
depending
my
on
point.
what you're
Thank you,
doing with
Juan.
it.
Thank you so much. That was my point.
Yeah,
But it was a
but
good talk about aerodynamics along the way.
Jesus Christ.
You're
the whole point of a model is to simplify something down and explain its main features relative to a certain need. If you need to test the aerodynamics, the thing that you need to be accurate about is shape and almost nothing else. You don't need to care about its weight. You need to somewhat care about it being rigid enough, but it doesn't have to be accurately rigid. It could be way more rigid than the real plane, right? Or structurally secure. If you're making a simulator, you don't need to be accurate in the way that the toilets on that simulator flush. And do they flush in accordance with an airplane flying? But they right, but they need to model physics for flying such a plane. So all models are abstractions, approximations, simpler versions of the real thing. Now,
Ronnie, I have a question.
in respect to a topic
Airplanes.
that you're
hang on, Aaron.
using a model for, that model needs to be reasonably accurate. That Play-Doh model is an illustrative model which shows which strata the Earth has, what are the layers of the Earth as you go from the surface to the center, and it illustrates them by just indicating them with different colors, and there would probably be an explanation somewhere to the side, or maybe it's somebody's school project. But those things which are indicated need to be in correlation with known science about what the shape of the Earth is, which has been deduced from literal observations, from measurements of how sound moves through the Earth, how vibration moves through the Earth, how the continents move relative to each other, and all of those things, right? What the magnetic field of the Earth looks like. And regardless of how many fields of science you take into account, in that model, they all need to coincide. You cannot have one model for the electromagnetic field saying there's an artificial electromagnetic generator, electromagnet creating the field which was built by dwarves, but in another model have it be hollow and have a central sun, because then those two things are in contradiction with each other. Right? So all of the models that you have in physics have to coincide with each other.
Wouldn't a more accurate model of the Plato cutaway there be if someone put, instead of using Play-Doh with colors the whole way through, maybe made a spherical shape, put some dirt along the outside, maybe stack some rocks just under that, and then under that put some real dense rock, maybe a couple pockets of oil, and then further than that put some quasi-molten Play-Doh, and then at the center just have this, bubbling ball of Play-Doh. Wouldn't that be more accurate from the information you just said about data?
It would be more accurate.
Right?
Yeah. It would be more accurate.
Okay, so the one that Sean showed is not anywhere near. I just blew Sean's Play-Doh model out of the water by adding like 5% of the information that you just told me.
No, but
so, hey, why not do it right?
Aaron, let me ask you something. If this was done as a middle school project, would you give them the wrong grade?
Say again, Sean?
If this was given as a middle school project,
after you're done.
If this was given as a middle school project, would you give them the wrong grade?
What do you mean the
I'm
wrong
not a
grade?
teacher,
Would
John.
you take?
Well, would you give them a
I'm
failing
not
grade for it?
What's that?
Would you give them a failing grade for it?
If I taught them that this is what the Earth is, Play-Doh, and all these colors,
How about this?
and they built that,
Aaron?
then yes, I would
How
give
about
them
this?
an A plus plus.
How about this, Aaron?
Absolutely.
If this is to you, okay, what if I was a teacher, you were the student, and I taught you about the Earth's core, and I said, and I showed to start off, I showed you this one, because this is the same thing. It shows the crust, it shows everything, right? I show you this. I say now, 12, 13-year-olds, go home and make a model of the Earth's layers. Unfortunately, or not unfortunately, in most cases, a kid isn't going to know how to make a model like this. It's most likely going to end up looking like that. It doesn't change the fact that it is a model, whether it has more information than this one or not. It's still a model. It still represents the layers of the Earth.
No, it only represents the colors that the kid saw.
No, it represents.
That's it.
Okay, now you're doing.
No.
Now I don't know what you're doing because
Right?
what you're doing is
now let's take a
disingenuous.
photo. Sean. Let's take show the kid a photo of an aircraft carrier.
No,
Right?
stay with this
and
one.
Say,
Go
home and make a model of this out of clay.
Stay with this
right?
one. Stay with this one. We're not talking planes anymore. We're going to talk to Earth layers. So tell me how what you're seeing right now isn't the same model illustration of this or visualization of this. You're just saying that the fact that this looks better.
It's exactly the same. Yeah.
Okay.
They're both beautiful.
Yeah. Guess what? One may have more details than the other. For instance, how come this one doesn't show you where the volcanoes are? How come how come this one doesn't show you where the vents for the molten lava is?
One was drawn by a physics PhD student. The other one was made by a first grader. They're both the same.
Listen to me. Does this model we're looking at right now mean that it's wrong?
There's nothing that tells me it's right. There's no looking at it.
Okay.
Look on its face. On its face. On its face.
You're right. Here, let me get this for you.
Look.
Hang on.
Yeah, if you showed that to an alien, they'd be like, "What is that?" You know. But I've seen that picture so much my whole life that I've got a bias towards that's what it looks like. Oh yeah.
Yes, but you realize that there are reasons why that image looks precisely like that, and why all those models that you have seen all your life look precisely like that. Right?
What about this, Eric? Does this work for you?
Well, they're all the same, Barney. There's never been a core section of the Earth that has looked different.
Actually, that's all of that is quite recent. It was presumed that the Earth was a rocky planet, and it is still considered as such, that it is solid through, or that there it might be hollow inside. All of those things were considered as late as the 18th century, right? The 19th century. It was only with plate tectonics and seismography and like fairly recent technological advances that enabled us to map what is inside the Earth. And it has to fit both material physics, acoustics, seismology, geology, right? Tectonics. It has to fit all of our other knowledge for it to work. And this is a model, like, regardless of how it's illustrated, if it's illustrated with Play-Doh, or if it's illustrated on a computer, or it's illustrated by me describing it, it is a model that fits all of those in describing the Earth. It is necessary that the Earth looks like that, or something really, really, really close to that, based on our known basic classic physics. Sorry, that was me.
So, Aaron, Here you go. This is a perfect example of how you're wrong. This is another. These are illustrative data that basically they would make that those models we were looking at. They would basically go here to find out all the information they need. That would be, the depth of the different layers, how thick different layers are, what they would be, the temperature of them. And so on. This is what you were looking for, right? You said you can't tell this, you can't tell that. Well, here you go. This is where you would derive a model
I
from.
didn't say you can't tell this or can't tell that.
Yeah, you did.
I said I'm partial to the
enough.
colored model. I'm partial to the colored model because that's all we've ever seen. Right. So yes, when you show me the Plato model and you're asking me, well, you don't never seen that? Like, yeah, I've seen that.
Wait, time out.
But if we're talking about an actual model with Barney, with Barney,
stop, wait. Again, what makes this not a model?
What, that drawing there?
No, you guys aren't looking at the drawing. You're looking at that project, the kids project, our school. The one that you didn't like.
Well, it's made out of modeling clay, so I guess I can't dispute that it's not a model.
It has nothing to do with it. Try again.
Yeah. What's your question?
Are you even listening? Are you here?
Yeah, but model.
Are you playing troll or are you playing dumb? Like which one?
No, I want to know because look, all that's represented there. It's not a model of different densities. It's a model of just color.
Did I say it was? No. Nope. It represents.
Said there's Earth's crust,
again,
the
Aaron,
mantle, and the outer core.
Aaron, stop. You are liable to be kicked every time you come on my stream. You need to start remembering that. So I'm going to say this again. A model does not need to depict everything. That's not what a model does. Now, if you want to keep playing this game, I'll notice it and I'll boot you. I don't care. Okay. So then we're pretty clear on what a model is and how it works. And I'm very happy Dan the Water Girl is here because that is actually the reason I wanted to talk about this topic. Let me go ahead and take this off my screen because I don't think it's necessary now that we have established Aaron is trolling. Again, like I said, we weren't trying to find density of anything. We're just looking at the Earth's layers. But like I said, the main topic at hand, the reason I wanted to have this conversation is the fact that a lot of flat earthers will use the documents from NASA, which is odd because NASA lies, I thought, to say that, oh, look, it says that Earth's flat. Well, it's a simulator. Now, remember earlier when Aaron was talking about how he flew a 737 and it was a hydraulic simulator, so you get to feel all the forces that would play upon you during a flight. Well, if we're playing a simulator on your computer, those forces make zero difference to you because you don't feel any of them. So in that case, it's not going to have to play. They're not going to have to derive something in a program that pushes down on the plane. They don't need to. What's the use? Why? Therefore, the shape of the Earth, gravity, those things don't matter in a computer simulator. That obviously doesn't make any of the forces are shown. And that's exactly how that program and the data and the information about that program is going to be written out. So when you see those NASA documents that say that, yeah, congratulations. All you've done is establish the fact that, yes, those things do not play a factor in that simulator. It does not depict all of the Earth and how it works. Make sense? It makes sense, Barney, how I said that?
Makes sense to me.
It made sense to me. I don't know if it makes sense to Aaron.
Yeah, no, he don't count. He wants to keep playing games. He can continue to do what he's doing on his own like that. But I don't really have time for it. So,
So I actually hopped on for a reason.
Yes.
To derail the conversation a little bit, since this topic seems to be beaten to a pulp.
Yeah. We can change it up.
You mentioned something about mean sea level.
Yes.
And That's an interesting topic for me, so I wanted to jump in a bit on that. Sea level is not actually mean sea level.
No, not even close. Or not. They are not the same. It's the best only way to really say it. Mean sea level.
So when we measure altitude, we don't measure them from the center of the Earth. We don't measure them from mean sea level based on an average of long-term data. We use a model. And we use a very specific model. We the human race, we the scientific community, sorry about the improper use of we. What sea level is in altitude is basically the the average strength of local gravity. So that you can imagine it like in the Himalayas, those mountains are made of rock and they're very heavy, and there's a thick layer of heavy rock beneath them, and gravity there is denser than, let's say, out in the open seas where there is a basalt plate which is fairly thin, and most of everything other is water. So we actually calculate what would be the surface of the level if there was no land mass there, but the gravity of that land mass was still there. And we use that as mean sea level. That gives you a couple of advantages, where you have then kind of a coincidence between air pressure at certain altitude, which is uniform all around the globe. You have the same direction of down all around the globe, because the down is then just perpendicular to your local, perpendicular to that local curve, regardless of where it's pointing. Because if you're standing next to the Mount Everest, it will be pointing slightly towards it, and will tilt you relative to what the perfect spherical Earth would be. That's all I wanted to say. I just find it so fascinating, and that shape, that curved shape, which retains all of the gravitational anomalies, is called a geoid, and it's one of the things that I'm using to solve Travis's question about how much in each picture, depending on time of day, should something be elevated or not. I'm using the geoid database for the Chesapeake Bay.
Barney, I have a conundrum.
Go ahead.
If you will, Sean. Or Sean, did you want to speak first?
No, go ahead.
I was on another panel today, something about water sticking to a ball, all that crap. And the most dominant answer from planet Earthers is, do you realize how... Well, that's the new term. Instead of saying baller, because I guess that's a bad term now, I'll say planet Earthers.
Just a second, I'll be back in 2 seconds, literally.
Say again, what?
Go ahead.
Okay, yeah. They were like, well, do you realize how thin the ocean is actually compared to the mass of the Earth? Right? Basically implying that when it comes to gravity and all this stuff, it's Anthony Riley, it's negligible to calculate for what you were just saying about flying over the Pacific Ocean. Because in relative terms, between the mass of the Earth, which is where I guess gravity would be based from, the main calculation, to an altitude of flight, like you're saying, there's wouldn't it be so minute? Not every mountain is as tall as Everest. In fact, most are half or a quarter the size. You know, the topography, there you go, Sean, of the Earth, if it was curved, wouldn't have... I mean, would that even be worth a calculating effect as per the description you were just talking about? I get what you were saying.
It depends on it depends on what you're trying to use it for, right? As all accuracies do. Like, sorry for the analogy, but if you're building a wardrobe and you miss by a millimeter or two, like you won't even notice it in your wardrobe. But if you're building a micrometer and you miss off by a millimeter or two, you have made a completely useless thing, right? So it depends on what the usage is. Yes, those differences on grand scales are negligible.
So if I could add something else, because this is my area of
right before you start,
specific
Tony,
expertise.
Right before you start, Tony, hang on. Aaron, I'm going to make this very, very clear. Your trolling is done. You will not interrupt, and you will not monologue, because I don't want you to. Thank you. Go ahead, Tony.
Yeah, so I've spent 25 years working in mapping, and WGS84 is like an old friend, very, very familiar to me. Yeah, so what they do with WGS84 is, as Barney has explained, they take a number of factors. But one of the interesting things it does as well is, and why it was very difficult in 1984 for them to have the World Geodesic meeting, to bring all of the mappers together to agree on this, because they had found through the use of satellites that there was a lot of imperfections in the system. Now, you have a set of different maps that existed pre to WGS84 as a projection, which is a projection. You had, like, there was a NAD, there was a North America system, there was a number of them. In the UK, we had a number of ordnance survey systems. You know, there's a number of different mapping conventions that existed. The military also had some as well, and still do actually have some that they specifically use.
The military one earlier, yeah.
Yep. So there's a number of different datums, and it depends what you're trying to do. Now, what WGS84 did, which was really revolutionary, and we needed it as soon as we went to GPS, we went to smartphones, we went to sat-navs, okay, was it also brought together a number of the anomalies within the world mapping coordinate system. So it does look at gravitational equipoints, and does manage to try to normalize and bring those together, tries to normalize and bring together sea levels or variations in sea level. But what it also does is try to bring together precision, because you have a number of physical surveying points, which are datum points around the world where surveyors use these points. And you also had to bring together and harmonize those. You had to harmonize them around geographic borders between countries, around properties, around areas that are measured. And typically, obviously, as human beings, we're much more interested in dense populated areas than we are in the middle of the sea in the Pacific or something, right, where there aren't any geodesic points that are sort of nailed into the ground with a little bronze plaque on it. So it was really quite complicated what they needed to achieve with WGS84. And of course, like any system, when you're bringing together those coordinates, there are still anomalies that you can find within the system. And indeed, there's websites that point to where some of these odd anomalies are, where you'll look at a distance on one coordinate system and then you look at WGS84 and it's slightly different. So I think it's really important for people to understand the amount of complexity in trying globally for everyone to agree on this, because it's actually very, very difficult to understand where we are within any coordinate system. And by using WGS84 as this geoid, which it is, it gives us a really good, rough, more precise way to harmonize between the different systems that we use. Sorry, you had some questions.
That's actually perfect, because then I would actually thank you, because of what I do also on the side on side jobs and when I'm starting projects is I do topo mapping as well. So,
oh yeah,
I need all that. When you were saying about the different projection views, I'm like, oh, it's perfect. You would be, so people understand, Tony would be the step ahead of what I do. Like, I need his information to do what I do.
Yeah, and there are a number of systems which I think we've spoken about before. Where you can use a full Cartesian coordinate system if you need to use that. I think the military specifically used that for a number of missile-based things. I've looked up some translations between WGS84 and Earth-centered, Earth-fixed ESEF is it, I think, that they use quite commonly. And there's a lot of quite complicated transformations that one needs to make when you're moving between different coordinate systems to do various different things. And it's really important because the translations, again, are always quite, they're not always as exact as you might imagine them to be, because you're bringing together different systems which are being looked at in different ways. And I think it's really quite a testament to the fact that, and this is one of the reasons, by the way, it's for me one of the main proofs that I believe that the Earth is a globe, is a sphere, is because I would ask where in the mapping system, if you just take something like Google Earth, right, because Google Earth is available to us all, if you look at that mapping system, you need to tell me where they are hiding the pieces of landmass. Because I would argue that surveyors and anyone who's got a sat nav and is driving around or traveling around the country can look at the system you're showing on the screen now, Sean, and you can work out exactly where you are. And you can look at your local area. You can verify pretty accurately your local area. Yep. And you can say, right, there's no anomalies around me. And then you can travel somewhere. You can say, there's no anomalies around where I travel to. The distances are match up to what the model, which is curved, is showing us. So then you have to start to say, well, they're going to crush it into the sea. Do you sort of mean? The argument has to be, well, in the sea, that's where they're, fooling us. And then, of course, you can start to look at airline flights and other things. So I think you have to say, where are they hiding this stuff from us? Because now we have it available. We can see it as you're showing on the screen. We can make our measurements across it. Yep. So I would really like people who say, no, it's flat, to consider that fact and say, okay, in that case, why, because on a flat Earth, obviously over scale, you would get larger anomalies if you were just trying to map it onto a ball. Because I have heard the argument, right, it actually is flat, but all they're doing is they're just mapping it onto a ball. Now, that works fine if you're saying very short distances. I accept you're not going to notice nothing, 2-3 miles, you're not going to notice very much. But over longer distances, absolutely. Because we already, by the way, in our mapping, already notice anomalies between the map sets that we use. So if I take an old 1969 Ordnance Survey projection, and then I map it to WGS84, I'm already correcting for a number of mistakes that are in that original mapping. Do you sort of mean? I have distances that don't add up, I have borders that don't quite meet, and then we have to do some kind of fragmentation on where we need to interface those maps together. If we're going from like an old surveying system, do you sort of mean from the sort of 60s, a land survey, maybe it's not been surveyed recently, someone's selling off their country estate. Yeah, we're taking an older map projection, we're then converting it to the newer map projection because everyone wants to look at it on the computer. And we have these anomalies, and then we need to move these points around. So I already see mistakes, do you sort of mean, just over the borders of Scotland, someone's large country estate, and from the old mapping projection.
Yeah, and that's a perfect example of how we know we have plates. Perfect example of how we know that California's coast is actually moving. It's not as if if surveyors go, hey, we have a great idea. How about we tell them different sections of the world are moving and not be able to show for it? I mean, you can show for it.
I think I'll show you how you can show that, Sean. Google, what do you call them in America? What do you call those surveying points? We call them Ordnance Survey. Yeah. So Google that, bring a few up, and I bet you'll see 3 or 4 where they've been corrected, and they stamp the date when they correct them. So in 1950, it will give an exact coordinate, and then you'll see that they've chiseled out the 1950 or whatever, and they put 1984 corrected, and then they'll put what the correction was actually on a physical bit of plaque, a bronze plaque that is on a hillside. You can go and find these points. You can look at it, and you can see that they're updating these all the time. Yeah. If you Google it, whoever's sharing, you'll be able to find some, because I found some before. Yeah.
Yeah, I have.
So to tie back
right here, I'm trying to see if they have the markings on them or not.
To tie back to the previous conversation, the geoid database is a model, right? It is not the real Earth. It is not the full Earth. It does not contain hills. It does not contain houses. It does not. It just contains the mean sea level and how much the surface of the Earth deviates from that. What is the local altitude from that geoid? Now, the reason why flat earthers are being asked for a model, any model, is that, yeah, sure, we used to have many different models and projections and maps and ways of measuring topography, and when you try to put them all together, none of them work. Some worked on large scale, some worked on small scale, some worked on... We are, through a long and arduous process, we have found one which accurately works on any scale, practically, right? That puts all of those together. And if you take all of physics and all of science as a model where things coincide with each other, where the behavior of the internals of the Earth coincides with geography, right? Where tectonics coincide with geography, and those coincide with physics, and those coincide with material technology, knowing what will happen to which material at which temperature, and stuff like that. All of those coincide mutually. That is what kind of points that this is the real thing. Because then you can go to the statements that I've given on this channel before, like we know how refraction works. If we didn't know, my glasses wouldn't work, right? So we know how refraction works, and we know how refraction works through air, and you can test it, and you can model it with water and sugar, and we know how tectonics work, and we know at which temperatures materials melt, and we know how sound propagates through those materials, and all of those things mesh together. They interact and they intersect, and they all describe the same universe. They describe reality. The way we have picked the models that you can make infinitely many wrong models, but the way that we have picked our model in science is that we have picked those things that work, not merely that explain, but that actually work, that you can practically use, that you can use to predict what's going to happen next, and what things are like somewhere where you've never been. And no, it is not perfect, it is not absolute, but it doesn't mean you can just say anything, right? I've never been to Finland. That doesn't mean that I can say that Finland is a desert island filled with unicorns, right? There are rules to what you can get away with, and that's why we're kind of asking Flat Earth to produce any kind of model so that we can check it against reality. Does it then mesh with everything else that we do? If you can do that, then yes, you will turn me into a flat earther, or you will actually have me seriously consider Flat Earth, because I already have a model which works. Until then, I will not really take you seriously. I will be curious about your understanding. I will be curious about your explanations. I will be curious more about your brain, about what are the things that make you believe this, and how do things look inside your head for you to be able to believe this when it is so obvious. I understand the argument, yes, locally when I look around, the Earth is flat. Every curve is flat when you zoom in as much as you can. Right?
Barney?
That argument stands. I can agree with that. And now let's take the rest of reality.
Sean? Can I?
Hang on 1 second. Hey, Tony, I'm looking on here. I'm not seeing. I'm where you told me to go, but I'm not seeing multiple stamps. I'm only seeing.
I've got loads. Yeah, I've got loads. So I'm looking at page 4. So if you go in and you find where there's one about 6 down. Click on that, and it'll give you loads. I'm trying to copy a link now of a really good example, which I will now try and put into your open chat. Yep, and then you can bring that up, and then you can have a look at that one.
Yeah.
So I'm just trying to do it now, but unfortunately I'm not in front of my computer. That's the problem. But I'll try and put it in your open chat now, which I'm just about to do.
Yeah, because like I saw a few that had a couple stamps, but it's like
here's a good one. Here's a really good one.
Yeah.
There we are. There's one on Reddit, and it'll probably link to more. So if you look in your open chat, and you can bring that up and bring it on screen, because I think it'd be good for people to see these, to realise how much effort goes into these, and the fact that they're restamped at different times. So generally what they do, by the way, as you know, is they melt them down and then restamp them, because a lot of them are made out of lead. Yeah. But this example, I think, the one I've just posted, has got at least 2 dates on it, which shows how they correct it. And they actually move these markers around and they reset them, and there's fines if you mess with them. It's pretty interesting.
Yeah, I'm going to right now.
Hey, Tony.
Yeah.
Oh yeah, I was looking at this one.
You're an actual. What do you call yourself? A geodesic surveyor, or how do you?
I mean, there's a good example. So no, I've worked in mapping for a lot of years.
Okay, mapping.
I don't have much to do with it these days, not practically, but I certainly spent 10 to 15 years.
Your knowledge field, like, how do I call that? So I don't want to misrepresent you. Like what?
GIS, I suppose you would say. So I worked in GIS. Geographic Information Systems is what I worked in. Yeah.
You've done a lot of work in which area?
All different areas of GIS, actually. mapping, surveying, digital mapping, digital utilities, digital land surveying, and then got into a lot of programming around GIS systems that are used.
Digital? What do you mean digital?
So digital mapping rather than physical mapping. So physical mapping is where people draw things on sort of transparencies and sheets of paper. Digital mapping is where that exists within a computer.
Like what we're looking
physical
at.
Mapping? Yeah, but wouldn't physical mapping be the guys out there doing line of sight, staking, stuff like that?
That's where they get their data from.
Yeah, so I think you're confusing. I mean, this is a whole industry, right? So there's a lot of different terms within it. Yep, and there's a lot of different expertises
that
within
would be surveying.
Yeah, so I think what you're talking about is guys who go in the field and hold up theodolites and that. By the way, if you go to my channel, there's an absolutely fantastic video on all of this, which explains all of the terms, shows you what a theodolite looks like. It's a very long video, by the way. Shows you what a dumpy look like, and then it gets into what Jesse does, Jesse Gonzalez as well. I got some data from it, but on my channel, very long video, but it's a very good one if you want to know about surveying and maps and map regions.
Actually, then I want to make sure I get that because I'm a hobbyist surveyor. I do the topo maps on a lot of my projects, and then I'm mainly a grade checker. So yeah, that's actually exactly everything I like to know about.
So local though, right, Sean? I mean, it's such a local instrument.
So
it's
I know how it works.
Dumpy is fine. A dumpy level is fine. You can use a dumpy to show curvature. Have a look. Have a look at my video. You'll see it there. Yeah.
Okay,
I mean, I think actually the theodolite was used, but you could have used a dumpy. Right, a dumpy is absolutely legitimate. You could use a dumpy to do it.
I would like to
you only need about 3 miles with an instrument. Yeah, that accurate.
I would just like to get back to GIS.
Sure.
The field.
Yeah.
There. So you've worked in a lot of, you said, digital mapping, digital works of lots of areas. Can you, where? Like U.S. or?
Again, that video, by the way, shows what I worked in. So I've worked in the U.S., absolutely. I worked across Europe. I've worked in the U.K. Because it's global information systems. Yeah. So, I've worked across the piece. I worked a lot in telecoms. I worked a lot with satellites and with satellite data, satellite information. It's been a lot of fun.
Have you ever worked south of the equator?
Have I ever worked south of the equator? No. Does that some way massively invalidate me by the fact that I've never been south of the equator?
I'm done trolling, Sean.
Thank you. Shouldn't have to say that though.
But I suspect that you could find people on this panel or other panels who have. I bet you could. Yeah.
That would.
And I never found any problems with any of the systems that we coded when they went to Australia, for example. We never found any problems. Yeah.
That was what was going to lead me to the question to Barney. I was going to ask him, let's say an azimuthal projection is perfectly accurate, just as the globe, down to the equator, right, out to the equator. But
no, it's not.
After that is where we run into a problem. If
no. It's incorrect. Absolutely not.
That
is not true.
Completely untrue.
Right.
What's wrong with the azimuthal looking down on the North Pole versus looking down on the globe at the North Pole? Except
for any latitude on the azimuthal plane, you will get the length of that latitude parallel to be the wrong length. You will get the wrong sizes of distances, right? Because when you flatten it out that way and measure it from the North Pole, the distance from the North Pole to that latitude times 2 pi will give you the radius on the azimuthal projection, right?
What is the purpose of the azimuthal projection map? Why even display it if it's nowhere near accurate? Why even have that as one of the mapping projection?
Same reason as for every other map, right? There is no flat map which accurately represents Earth. All of them have to distort something. You cannot project an object with Gaussian curvature on a flat surface.
If there's no flat map,
you just cannot. You have to lose something.
Why do we only use flat maps?
Don't.
Why?
You're using a
We don't
projection.
always
First
use
of all,
flat
these
maps.
days we don't, right? Since the invention of, as I say, digital mapping, we don't, because we can now use models.
Globes exist for
Plotting
hundreds and
course.
hundreds of
Exactly.
years.
Yep.
Plotting an
And
airline course. Plotting an
hang
airline
on.
course.
I had
does
another
not
point
take
about your
into
AE
Why,
effect
why do
projection.
we use flat maps? Because they fit in books. Because you can take an
They're
atlas.
convenient. You can fold them up. Yeah, you can put them in your pocket.
Even on large scale, though, right? I could have a flat map
So
of
hang
the
on,
United
hang on.
States.
I'd love you, Aaron, to find me a use case of the AE map, used for anything more than just positioning, right? By which I mean a small thing that's displayed on the screen. In fact, I think they've even withdrawn it from a lot of the weather maps. So when you're doing some computer modeling and that, I would like you to show me a use case for the AE map at scale. Yep, just one example in the northern hemisphere.
Cody,
Yeah.
that's not where I'm going here. Yeah,
It's
I'm
okay,
not-
but
Well,
said it
you
was
brought it up.
perfect.
You said it was accurate.
perfectly accurate
Aaron,
for the
you
northern.
made a statement earlier on. You said it was perfect down to the equator. Yeah.
I was
I'm saying
asking
just show me a
Barney.
use case.
I was asking Barney. It is not a azimuthal projection.
It is not.
Exactly the same, and Barney made it clear. Yes, that's right. I was missing the curvature. That's right. I was leaving out the curvature, wherein you wouldn't see. If you're looking down from the North Pole on a globe, you couldn't map basically the bottom from 30th latitude down almost, right? Because it just wouldn't. You couldn't see it. It wouldn't fit. You couldn't. Everything would be all weird. Right,
It
Barney?
depends on how far away from the Earth you are when you take that photo. It also depends on what your criteria for precision is, right?
Sure.
If
Yeah,
if your tools are precise enough and you are a stickler about precision enough, walk away 100 meters from the North Pole and it no longer works.
Exactly.
Walk away 1 centimeter from the North Pole.
And that's why I make the point that they use it in weather projections, tornadoes, maps like that, where they just want to provide information to people and they don't need an element of precision, and it's a useful map view, right? And that's why it's used, yeah?
Okay,
and you'll
cool.
typically
So-
find
so
it used on weather maps, yeah?
all
Where
the-
people
all
want to
the
look down
useful-
from the North Pole.
All the useful stuff that we need to know is projected off of a basic flat map. That's pretty nice. I like that.
That's not what was said.
Sorry, Sean, I was trolling.
Yeah, come on, man. Well, let's strike two.
Sean, real
That's
quick,
what
did
Toby
you,
said.
That
That's
doesn't
what Toby
even
said.
count as trolling. That was just trying to be
Yeah.
funny and failing spectacularly,
And I
but
was agreeing with
trying
Toby.
to be funny.
Yeah, you just failed badly.
Sean.
Yes, sir.
Sean, did you see that link I put in the Discord for the gravity wave?
No, but I'm going there as we speak.
Yeah, it's a long link. I just clicked on it and said, "Oh, this is cool," and put it in the Discord.
What,
But
when did you do it?
okay,
Yeah, it's the Google one. It has a little Google.
yeah,
Actually, I put that on my
Yeah.
website.
yeah, it's pretty cool. There's a little video that they put on Twitter and stuff, but it actually shows that gravitational or that gravity wave coming over Australia. It's awesome.
I'm there right now. I'm looking at. It's the first. It's like the Twitter video.
Yeah. There's 2 Twitter videos on there. I think it's the second one
Okay. Yeah, I'm looking at
that
it now.
actually shows it.
I'm gonna get it ready and then I'll play it. Oh, I see.
In the
Okay.
meantime, Barney, since I guess we've moved out to space and gravity waves, I have a question, and about models. It's relevant to Sean's topic. Simple
Topic
yes or
goes
no
everywhere.
answer.
Doesn't matter.
Yeah, simple yes or no answer, Barney, just to get through up to the point that, do we have a model of Earth? Yes, right. Do we have a model of the solar system?
We have many models of Earth and we have many models of the solar system.
Cool.
Well, I'm
Do we
not
have
sure what
any-
you're
do we have
asking.
any models of the, let's say, Milky Way, wherever the Earth solar system is? Do we have a model of that?
No, we have a very rough approximation, but we don't actually know what the full shape of the Milky Way is because we're in the plane of the Milky Way and we can't see through all the dust that is through it. So we actually don't know what the complete shape of the Milky Way is.
Okay, so no model of where the solar system is.
But how will we know where we are in the universe?
So that's why I asked, what do you mean by a model? Do we have an approximation? Yes.
Can you make it?
Sorry, I fucked
If
up
I
your
gave you
trolling,
some
Aaron.
Play-Doh.
Sorry, I fucked up your trolling, Aaron.
And that's why we're still sending probes out, right? We send probes out to find out more, right? That's why, Voyager and various others are sent out, yeah.
Oh shit!
To model things better.
I can see 400 million light years.
Wait! Stop! Sean, that's a gravity wave.
Yep, that's a gravity wave.
Barney, do we have an illustrative model of the universe? Because I've seen one.
This is
There's
real?
there's actually there's another image of it, I do believe, in another one of the videos.
So
it actually shows it a little bit clearer.
Is that water vapor or something creating a gravitational effect, or is that actually a gravity wave? Because it looks to me like it says water vapor, visible light.
Yeah, but that's it's water vapor and then basically gravity rearranging itself.
It's from the.
That's what's so cool about it.
It's from the Himari 8 water vapor, visible lighting, and observation. So yeah.
Yeah, and then behind it is a cloud of dust that comes off of Australia and heads towards Africa.
Okay, because I thought that only detected one gravity wave with LIGO, and they were very lucky because it was just after they turned it on.
No, it's not a gravitational wave; it's a gravity wave.
Right.
Okay.
Now I understand. Right, because I was a bit confused. Okay, right. It's not a gravitational wave, exactly. Right. Okay, fine.
I'm sorry, we were interrupted. You were asking, do we have a model of the universe? Well, we have some observations. We have some things mapped accurately, positions of most of the visible galaxies and some of the farther ones and stuff like that. We do not have a complete model of the visible universe. We also have models, as in physical models, as in physical simulations, such as Illustris, which takes the basic physics and simulates the universe through them using some assumptions, and actually shows how galaxies are formed and how the grand scale formations in the universe, like that coincides with those observations that we have made about where the galaxies would be in the universe, how far apart they would be, what would be the voids, what would be the filaments, what would be the nexuses, what would be clusters and stuff like that. So since our simulations actually fairly accurately produce a universe which can be correlated to a universe that we have, we kind of accept that at least that some or most of what we already know is confirmed through that. Does that answer your question? In that sense, we can model the universe, but we do not have a model of the universe, as in the same way that we have a model of the solar system. Even the model of the solar system is incomplete. We have most of the big stuff down.
Sure. And you used the word would, like if something would, if it would be. You use that a lot, and I don't blame you, because it's apparently abstract. But there are representations of what you just gave to me, literally, of this. Well, if this, then that would be, and I've seen pictures of it, right? Everyone on the panel has, even all flat earthers, we've all seen these pictures of the universe, right? Can you at least concede to that and be like, yeah, we've seen illustrated representations of the universe?
You mean the large-scale structure, that foamy, the one that looks like soap foam?
Yeah, this spinning disc with the great attractor with all these foam things going around it, right?
Huh? Oh, sorry, you're talking about the galaxy, right? We've all seen pictures of the Milky Way galaxy. Is that what you're asking me?
Sure, that and bigger, right? I've seen pictures of bigger than that.
I mean, they're representative
When
models,
you
aren't
say
they?
the great attractor,
Illustrations.
great attractor is a cluster. Great attractor, is it
I don't really know what the great attractor is. I just threw that out there.
Mauna Kea supercluster? Is that the correct name?
I'm
not
just
sure.
saying, you guys have seen that image of the cloud of galaxies that kind of looks like a plane, but I'm not saying it's anything relative to what we're talking about. But it kind of, and you've seen those. Have you
got a
seen
problem.
okay,
Hang on,
fair
hang
enough.
on,
Yes.
hang on. Stop.
The-
I
the-
got a problem. I got a problem. How are these gravity
simple.
waves?
What?
Gravity waves don't cause dust, by the way.
Doesn't
Sean.
aren't gravity waves like super fast? Speed of light?
That's what we just touched on earlier, Sean. They're not, they're
They're
not
not
gravitational waves.
gravitational waves. They are gravity waves, which is a completely different
Thing.
Okay.
It is not a wave of gravity.
Yeah,
All right. Yeah, I had my headphones off for a little bit. My bad. I missed that.
yeah, because we we discussed that a little while ago. Because LIGO's only detected one. I think I might be wrong. They might have done more.
No, I
but
think 3 at this point.
I think
is
two,
it okay? But
yeah,
yeah,
2
not
or
many.
3.
Yeah, not many is the point. Yeah.
Okay, so this is that. Okay, I'm sorry because I know, man. My bad. So, an explosion can do this. No.
Right, but not on that magnitude.
Okay. Perfect.
Yeah, that's Australia, so that just kind of tells you the size of it.
Project Fishbowl.
I just said that, and he said bigger. So no. Stupid ass. All right, cool. Thank you. I'm sorry.
So,
and I do
Barney-
apologize.
Yes, we do have measurements of approximately where other galaxies are, right? Based on
Barney, I don't want to interrupt. I mean a model. A model.
Yes,
I know-
we built our model based on those measurements, and then looked for hypothetical explanations of what would explain that. Then used that hypothetical explanations to simulate the universe, and got the same or more or less the same results, right?
even from untestable, unmeasurable distances, things, physicalities, abnormalities, abstracts, right? But what I'm saying is, that's fine. Hey, you guys are awesome.
Can I ask a question, please, in a minute?
Real quick.
I would like to get to Aaron's question. He's been setting up a question for ages, but never seems to get to it.
So we've got this model of, as far as we can see, whatever it is, that picture they show me of the, whether it's the galaxy, it's more than the Milky Way, it's kind of the universe. They kind of show that. But on a layman's scale. Because yes, we don't know the extremities of the universe, apparently. Okay. Barney, here's the question. Do you have a model of the Big Bang?
No, we do not know.
Wait, Barney.
No.
Wouldn't the projection that we see, the microwave background, isn't that a model?
No, so that's a measurement, and that is not a measurement of the Big Bang. That is a measurement of an event which happened 300,000 years after the Big Bang, when everything cooled down enough that electrons could finally stick to their protons and form helium in its elementary state. And from that moment on, the universe was no longer plasma, and light could move through it, because plasma is opaque. plasma
in a
will
Big
not
Bang.
let light through, right?
So I've heard it said before that we do, Barney, have a mathematical model, I think it is, or pseudo-physical mathematical model of what, 3 seconds after the Big Bang or something? I've definitely heard people say that before.
So we have a model. Our model goes back to 10 to the minus, I think it's minus 36 or minus 42 seconds. So 0.42 zeros and then 1 seconds after the Big Bang, which is the Planck time, right? And we can model that hypothesis that far back. We cannot model what?
What would the shape of the matter be that was discharged from the Big Bang? If it discharged in all directions from a center point, a 0 point, what would the shape? Everything would be moving away from that Big Bang at the same rate, at the same speed, but yes, I agree, expanding out. What would the shape of that Big Bang be, and why do they show me a flat plane?
So that's a common misconception. I literally cannot answer that question because the question presupposes some things which aren't true in the model. It's not like there is a lot of empty space and then at one point there is an explosion and all of the matter starts flying into that space. There is no space. There is no time. There is nothing. Literal nothing.
So the Bang.
So the Bang, even though at the point of singularity, all of the points of the universe are contained within one point, and there are no points outside of that. The Bang didn't happen at one point. It happened everywhere in the universe simultaneously in all of the space that exists, and right.
But no space existed, right? No space.
But wasn't all of the points the same point, Barney? Surely, if
all of the points were the same points. All of the points were the same points, and those points have been moving apart from each other since then. But it's not a sphere that's expanding into the void. It is not an explosion from one point into the void. There is no edge of the universe. It is space and time itself were created in the Big Bang. But space, the distances of space were so compressed that everything was on top of each other.
Okay. So 1/30th of a millionth of a second after the Big Bang, is there in the mathematical model of the Big Bang, is there a direction in which the bang happened? So I get you. If I light a firecracker, somewhere,
no, not the same thing. Not the same thing.
Now,
Imagine.
I'm not saying
it's
that
not
happened.
the same thing.
I'm not saying it happened.
You can't look at it like a firecracker.
Okay, so Barney said that actually there was, by the time we can calculate back, things were already expanding.
Yes.
Right? We can't get back to singularity, basically.
We cannot get back to the singularity, and we do not know whether there was a singularity.
Are all these things expanding away from the singularity? Or they are not expanding away from the singularity?
No, they're expanding. They're expanding one from another. In a very real sense, if the singularity hypothesis is true, if that is the explanation, if the Big Bang really did come from a singularity, then we are still in that singularity.
So, rephrase that for a layman.
The universe is that singularity. We have never left it. We didn't go from the singularity somewhere else. All of space is within that singularity. That singularity expanded so that every point of space within that singularity got further from each other.
Yeah,
but they didn't go further from the singularity. They didn't go further from some central point. Imagine it like this. Take a balloon and draw some dots on it, and then start inflating that balloon. those dots will move apart from each other. Whichever perspective you look at it, every point will be moving away from every other point on the surface of that balloon. But there is not a single central point that all of those points are moving away from, or you can arbitrarily pick any point and measure all the others, and all of the others would be moving away from that. So in that respect, as far as the visible universe is concerned, your eyes, your literal head, is the center of your visible universe. My visible universe is slightly different because of the distance between us, and my visible universe is centered on my head.
Absolutely. Let me ask you a question. Who's blowing up that balloon?
That's a non sequitur question.
No. It was your example. You said imagine some Tic Tacs on the outside of a balloon and blow it up. Who's blowing up that balloon?
There is no requirement for there to be a who for the balloon to be blown up, and a balloon is an illustration of how things can move away from each other. It is not the statement of the universe is a
this
balloon.
is where analogies break down as
What about a
as good
universal
illustrations.
force? Okay, yeah. Maybe not a dude blowing it up, but what about a universal force? Something that is making your head move away from my head. Right?
The statement that I've made was to illustrate how things can be moving away from each other while at the same time not moving away from a single central point, right? It is not the statement of the universe is a balloon that's being blown up.
Yeah, but
it is not.
Your statement wasn't quite accurate because the balloon has a center in that example.
The balloon has a central has a center in a higher dimension, right? It is a 2D surface. It is a 2D curved surface, which has a center somewhere in 3D, not on the surface.
Yeah. A point. Yeah.
But as I said, I want to emphasize this again. The universe is not a balloon. The universe is not even a balloon with a 3-dimensional surface which is expanding into the 4th dimension.
So I have a question. If in your analogy, and I know it's not perfect, it's just you were giving it to me. Why?
It's just an explanation of how points can be moving away from each other while they're not being a central point. It's all there is. There is no content in there beyond that I intended to say.
Aaron, I think the way you're asking it is wrong because I actually have an issue with what we're talking about. So, Barney, you're saying the Big Bang did not happen. It didn't happen like an explosion does, where it starts at 0 and then it expands. Not how it worked, right?
Yeah.
Okay.
Yeah.
But when we look back, if we're using general relativity and geodesy, I think I said it right, it does lead back to a single point, a 0.
Yes.
Isn't that a problem?
No.
Okay. So the Big Bang didn't happen from one spot.
It did and it didn't. So if you rewind time enough, all of the points in the universe occupy the same point.
But then
we cannot get that. Would be a singularity.
But then what happened?
We cannot get there.
Yeah,
our physics.
What was before that? What happened before that?
We cannot even get to that.
So
right?
In a sense, it doesn't exist.
Our physics break down before you get to that point. Before you get to that point, you lose any meaning of what space and time means. You can no longer mathematically describe it. What energy is. All of our physics become kind of useless. We're talking about a regime which is something like a black hole, but where the space itself is so where the space is dense enough that it doesn't collapse in on itself, and you get into effects of quantum physics being way more effective than gravity, and literally not having having the precision and math and understanding to describe what that is. So we
Question,
cannot
Barney.
get there.
How
Go
do we
ahead.
know that it is whatever 10 to the minus 47 just before the Big Bang? Then, if we can't, how do we know?
we don't
So
even
it
know
could be
that,
a billion years away.
yeah, and I thought I was clear about that. We don't even know that. That is the theoretical reach. The things that we do know is that we have background radiation. That background radiation coincides with some of the models that predate it, right? It coincides with the physics that we do know. It tells us that yes, it was much more dense. Yes, it was much hotter. Yes, it was. But everything beyond that point is kind of cannot be verified, cannot be tested, cannot be measured. It is opaque in every way. There is a chance that we might get slightly farther with gravitational waves if we get good enough at detecting them to use them as a telescope to seeing beyond the background radiation. But everything beyond that 300,000-year event of recombination is just extrapolating from known physics. We don't really know that. We deduce that based on things that we know now, right? And we can get to one Planck time after the Big Bang.
So I guess my view is we started from some very, very solid things. We were talking about maps and sort of our local landscape. We took it out to the world. We took it out to the solar system, the universe, and then back to the Big Bang. I had a question for Aaron, actually. Have you looked at a good model of the solar system, an accurate computer one with the correct distances, and played around with that? Because I have noticed, I'm not saying you're like this, but a lot of people on more of the flat Earth side have a problem understanding sort of three-dimensionally how things happen, right? I've seen lots of stuff about the umbra and the penumbra and the distances from the moon and how that couldn't possibly happen, and it should only be 10 miles wide on the Earth for the shadow and those kind of things. And so the other day, in trying to understand it myself, because unlike Barney, I have trouble visualizing these things easily. Yeah, I can, but it takes me a lot of concentration to do it.
It takes me a lot of concentration to do it as well.
All right, you seem better than me at doing it. So I went and played with a really good model I found, an accurate one that was distance accurate, and you could move the Earth around, you could move the moon around and put them in positions and then see how the shadows worked and things like that. Maybe for some of the audience as well. Because when you look at it in 3D, so I saw this video, but I can't remember what the chap was called. But he's quite a big flat earther. He does a lot of these flat things, and basically he'd completely misunderstood how the shadow is created on the moon. He thought it was the Earth's shadow that is on the moon, that makes the moon's phases, because he's just basically arguing around this sort of flat 2D model. Yeah. So I guess, I think it is important that we understand certain objects in the solar system where we have reasonably accurate models, to really look at them in 3 dimensions, because otherwise they get very confusing. And if you look at it from a TD point of view, you can't really work these things out at all. Yeah, they just don't work, do they?
Is that a question for me?
It is, yeah.
Yeah, I'm not one of those that thinks moon phases are caused by a shadow of the Earth. But let's move to the lunar eclipse. You've modeled out a solar eclipse, obviously. And
Yeah, well,
everything works out. So let's put a larger body in front of the moon and do that same program, whatever you have.
Mm-hmm.
And why? You tell me. Why can I still see the moon during a lunar eclipse?
Talking about a sun. Talking about a sun.
Yes.
And that's
Sun,
only,
Earth,
before you say
Sun,
anything
Earth,
else,
moon.
understand this. That is only count for 10% of the lunar eclipses that have happened. You understand that, right?
No, I
there's
haven't
a whole
looked into it.
90% of the lunar eclipse that we've observed that the sun was not visible. You understand that, right?
No. A lunar eclipse where the Earth
good job.
moves
Yeah. A lunar eclipse, a normal lunar eclipse, you do not see the sun.
Yeah, of course.
So shall I explain?
It's nighttime where I'm at.
As an
During a
interesting
lunar
discussion,
eclipse.
I'll explain the argument,
phase,
right?
Yeah, not a phase situation, Sean. I'm talking about a lunar
Yeah.
eclipse.
Congratulations. And when do you see that? You said you see it at night, right?
Always. Yeah.
Yeah. And there's no sun, right?
No.
Okay. Well, guess what? During a lunar eclipse, there's a whole half of the Earth that has a sun. Not possible on flat Earth.
Yes. We're not talking about flat Earth. I just want to know why I can still see the moon
Yeah.
So
in the
can I
solar system
explain?
model.
Mhm, mhm.
In the solar
Can I
system model, yeah.
Can
Sean,
I
stop
explain?
getting on the fucking pretext that I'm just always talking about flat Earth.
You got to keep
Right?
talking about
Right.
how you're a
Talking
flat
about the
earther.
solar
Are you a
system
flat
model.
earther? Are you a flat earther?
Okay.
It's definitely not spiritual, bro.
I think that Sean misunderstood your question.
No, I was
So
attacking
so
Aaron on purpose.
He's all right. I know.
Ah,
He's
so
you're following. Okay.
Can I just shall I explain what the problem is, and then we can talk about it, all right? And then I'll just be clear because I probably wasn't super clear. Okay.
Let me ask
guy-
you, Jody, my question specifically before you
Okay.
go on.
Okay, I think it's related to it, but
Yeah, solar system. We see it. You have this program. You can do the solar system. You've modeled sun, moon, Earth, and you can model the shadows, the rotations. You can model all that, right?
well, shall I explain what the problem was and why I went to that model, just so we all are on the same page, because it is interesting and you'll be interested.
Well, I would like you to move the moon to the back side of the Earth.
Exactly.
and
So let me go slowly, and then we'll get there where you want to be. Okay. The guy had this point, and it was an interesting one, which is why I went to look at the model. All right, and then we can discuss it, just so everyone is on the same page. There's two events. There's one where the moon is blocking the sun from getting to the Earth, and there is one when the Earth is blocking the sun getting to the moon. Okay, so like you say, the moon is on the back side of the Earth, or the moon is on the front side of the Earth, right? In one instance, you get to, I think I've got the thing written down here, of the Umbra being something like, I think they said 267 kilometers. That might be the penumbra, actually. And then they wondered why, because the moon and the Earth are not, they're only 2.6 times the size from each other. Why is the the Earth shadow on the moon 9,000 kilometers wide? Do you understand the anomaly? Yeah, when the Earth is blocking the moon.
2.6 difference or ratio. Is that a ratio?
Correct. The ratio is only 2.6. So the moon is 2.6 times
In
smaller than the
comparison to
Earth.
what?
So why is it not making a 2.6 times shadow? Why is the shadow
talking
so much
about-
bigger?
Okay, overall diameter, right, between the two. That's what you're talking about.
Yeah,
Or
so
2.6.
2.6 diameter difference is what the guy said. Yep. I've not checked that, but it sounded
that
reasonably
guy?
accurate.
I don't know. I thought you were saying this. I don't know who that guy is.
Well, I don't know. I
Yeah.
need to go and look up who he is. But someone said this, which is why it worried me. So I went then to look at the model, right?
I still think that
Carry on.
Aaron's question is way, way, way simpler than that. Right? He is asking if the moon is in the Earth's umbra, if it is in total shadow,
Yes.
why is it that we
Why
see
not?
it? And
Yeah.
and the Earth being much larger than the moon, it would definitely cover up all of the sun, as opposed to the sun and the moon having the same angular size, so they just about cover themselves.
There it
Right?
is. Thank you, Barney.
So why is it that the moon is not black? Why is it red? Why
well,
do
we
we
know why,
see
because
it
of
at
that,
all?
yeah.
And the reason why we see it is refraction.
No, you can't use refraction out in space and on Travis's videos. You can't do
Atmosphere.
the
No,
same thing.
I'm using it. I'm using it on Earth.
No.
I'm using it on Earth. Earth has a layer of atmosphere above it, which is translucent, and it is a
Which way
gradient. It is a
Which
gradient.
way does it bend light, Barney? It bends light down, right?
It bends light down. Exactly.
Okay. So it doesn't bend light to the moon, right?
Yes, it does.
What?
That's the whole point.
Oh,
Look,
here we go.
if
That's why it's red.
if you draw a straight line from the sun through space that touches the circumference of the Earth, that touches its edge, right? It will get bent slightly down and pointed at the moon. And also, the light which will get bent down most will be red light. same reason why we see red sunsets and red sunrises on Earth is the
Not even
reason why you see a red moon during the lunar eclipse. Because the light all around the Earth gets bent through the atmosphere and strikes the moon. That's a lot
so
less
the Earth,
sun than direct
does
sunlight.
not.
But that same concept has been proposed to literally use the planetary atmospheres as telescopes.
Yeah, I know. So the Earth itself does not, cannot, and never will ever exhibit a shadow, ever, into space, ever.
It does. That
Where?
is a shadow.
When?
It's not.
I just rumpus right there. Sorry about that.
Okay, fair enough. That is a shadow, right? When you stand on Earth and cast a shadow on the ground, that shadow is not pitch black, the perfect blackest thing that you have ever seen. But it's still a shadow.
The Earth cannot, will not, and can never exhibit a shadow into space due to refraction. Into space. So, ever.
Wait. What? Say it again.
It does. I've just told you that it does, and how it does.
Okay,
Right?
so how come we
Shadow
never see
shadow is not perfect blackness.
Ayo.
And in the umbra on Earth, right, when there's a lunar eclipse, you don't suddenly find yourself in pitch blackness with no light whatsoever anywhere. Right?
Sure,
You still
wait,
see
wait.
things around
Are
you.
you sure? Are you sure? Seriously, I don't know if you're sure or not.
Am I sure?
Yeah.
I'm sure.
Are you sure?
Yes.
All right.
Yeah, I'm sure. When I was in, when I saw the
I'm
eclipse,
pretty sure they're sure. So I think you're wrong, Aaron. I'm not sure, but I think I'm sure.
Hey, this Earth's atmosphere and this reaction, this water layer that we have surrounding the Earth. Obviously, that's what refraction is, right? You know.
No,
Yeah.
that's not what refraction is.
What is the light refracting off of them, or refracting towards,
Light.
or away from them?
Refracting through
Atmosphere.
is the preposition you're looking for. It is
Yeah.
refracting through air.
What is air? Come on.
Serious? We really
Air
have to
is
know
a
what
mixture. Air is a mixture of gases.
Yes. Predominantly what? Nitrogen.
Predominantly nitrogen.
Helium, yeah. And do we have any experiments of a laser being shot through nitrogen, showing it refracting?
Aaron, that's a good question. I have a question. Is Google broken on your phone?
Oh, that was awesome. Oh, that was timing like
Not through a fish
I am
tank,
saving
because
that.
you cannot
I'm saving that
encapsulate
clip just so you
nitrogen
know.
without a container. You can't do it. I can't shoot my laser through a steel bottle pressurized full of nitrogen. I can't do that. Sorry, Sean.
No, but you can shoot
Aaron,
it
do
through a
you
glass
believe-
bottle full of nitrogen. But that's
Do you
not
believe
going
that
to
there's
give you
a
much of a
container?
result. Right?
It won't give the same result. You're right, Barney.
No, it will
Aaron,
do the same. You will just not be able to construct a bottle of significant size
So
enough.
we're gonna sit here, all of us. I accept Barney's response. I accept.
Okay.
I accept Barney's response. We're all gonna sit here and say that the Earth cannot and does not and will never exhibit a shadow, an observable shadow into space. So Hubble will never ever pick that up. No.
It
not
exhibits
what
a
he said.
shadow into space. That's what a lunar eclipse is. It is a shadow of the Earth on the moon.
If the moon's surface is so reflective and so, just so small, and we do get what is it called, an umbra, the outside one, the umbra,
The outside one is penumbra.
penumbra. We get the umbra from the moon.
Yes.
Why is there no penumbra?
at lunar
Why is there
eclipse,
no
when the
penumbra?
moon goes dark red, it is in the Earth's umbra. It is not in the penumbra.
Say again about the 70-mile shadow. Is that the what I'm visualizing? Observer.
The 70-mile shadow on Earth and the 9,000-mile shadow on the moon are umbras. They are the real shadows. They are the full shadows. The shadows that you get when there is no direct line of sight to the sun, to sun.
Darkness or no direct rays of light, right?
Yes.
So we're saying that the Earth, when it's in between the sun and the moon,
yes,
those light rays travel around the Earth.
Yes.
In such uniformity, with no clouds, no cloud layers fucking that shit up, no nothing, and it's red for some reason, that it does still show the moon with not even one singular point of a shadow. Like, hey, we can see that. Even though Venus, we can track across the sun for some reason. We can see that. There's no umbra on Venus.
Oh, you can track the Earth across the sun during lunar eclipse
we can
if you're on
track
the
the
moon.
Earth across the moon. You can't even track this little pinpoint shadow across the moon at all. But yeah, we can track Venus across the sun.
No, that is full shadow. That is full shadow. That is the umbra. There are no direct lines of light coming from the sun to the moon.
Yeah, hey, Astro Rex. Hey, Aaron, Astro Rex is actually a really good example of Earth's shadow. You ready? The ISS goes into the Earth's shadow every 45 minutes. You understand? Get it?
I'm waiting.
You didn't just hear me.
No, say again.
Jesus
Travis
Christ.
was emailing me. No, I had
Name dropper.
a couple emails. Sorry.
Damn. The ISS goes into the Earth's shadow every 45 minutes. You understand it? Do you get it? I doubt it.
And when
say again, the what? The Earth?
the ISS, the International Space Station.
Jesus Christ.
Bring up the map, Sean. You know the one where it's got that sort of U shape on it, where it shows you
on the Earth every 45 seconds or 45 minutes, right, Sean?
No,
Say again,
it enters into Earth's shadow every 45 minutes.
But how come it's not red?
It is when it's entering and when it's leaving. It gets shown. It gets shown on by the red light of a sunset and a sunrise. Same thing as the moon.
Barney, when it enters and then when it leaves, what does the camera catch when it's not red and it's moving into the behind the Earth and then coming out and then it's red again? What color is it then on camera?
Hang on, I have it. I'm gonna play it right now.
If you say it's black or a shadow, what we would normally call a shadow, Barney. Then y'all got some explaining to do.
What? No, we don't. What are you talking about?
What? So okay, I'm still trying to grasp what your problem is, so that I can try to explain it in a different way.
I think
otherwise,
I know what it is, Barney.
All that it looks like to me is that you're trying to twist my words to say something that I'm not saying, or that you have a drastically different
I know what it is.
vision of what it looks like and how it works. That it makes it seem impossible to you, in which case I would say you have a wrong image about it.
Bonnie, I told you, I cannot argue with you. You are right. Everything that you say is exactly what makes sense. Sean was the one who brought up the ISS.
Just wanted to say that out loud.
I'm not twisting your words, Bonnie, at all. No, never, because it makes sense. I might not agree, but it makes sense. I can.
So basically, the light that passes by the Earth, if it passes outside the atmosphere, it continues on its straight path. The more it gets, those lines of light, the closer to the surface of Earth you get, more bent they will be, because the gradient of the density of the atmosphere gets steeper, right?
How much in
Do you know what the
reduction
steepness
of light?
of a gradient is, right?
How much
It
in
gets
how much in
so
reduction of light power, whatever you'd call a sun ray, that power, once it hits the Earth's atmosphere, even those outer extremity rays, and then of course the other ones come in closer and actually hit the Earth. You know, we have daylight on one side of the Earth. How much power would it take to continue on and light up this 250,000 mile away? Like I'm not discounting the power of the sun. I'm just saying, just asking, actually. Like once the light starts to reflect and diffuse, what?
a single ray of light, a single photon does not diffuse.
But it can change. What would you call it? Direction?
It changes direction, exactly. It changes direction in proportion to its frequency, meaning that red light and blue light will be bent slightly differently, right?
Yeah.
Where red will be bent most. And you can test that with a prism, like when you take white light and run it through a prism. You can even take a glass of water that you have in front of you and just run a thin stream of white light through it, and you will see it dissociate into rainbow colors, with the red being shifted most.
In
right?
a prism, though, if you shoot white light at a prism, red always comes out from the top of the prism, right? Let's say it's a Egyptian pyramid prism. You know, it looks like a square base pyramid. Red always comes out from the top, right?
I think it's bottom. I think that the red one gets bent most, not least.
We'll have to check into that.
Because that bending is also proportional to the momentum of light, and momentum of light is proportional to the frequency, and red has lower frequency than blue. So yeah, I stand by my statement. Red gets bent most.
I think they all get bent the same, actually, don't they, Barney? Because a prism, you know, the exiting angle, whatever, not the angle of incidence, but the exiting angle. They're all the same. It's just time, right? Time to get through the prism, isn't it?
No, because otherwise they wouldn't split up into the nice prismatic colours that you see.
That's what time does, right?
No, nothing to do with time.
It has something to do with time, in respect that based on its index of refraction, each material slows down light proportionally to its index of
But that's not
refraction.
the explanation for why we get a rainbow.
That has nothing to do with this. And light bends, like the angle that it enters in will be proportional to the index of refraction. Another thing that the index of refraction will be proportional to is the density of the matter. That more of the refracting thing that you have, more it will bend light. So when you take that gradient of the atmosphere, where it's really, really, really thin at the top and somewhat dense at the bottom, right? That difference between density will create the difference between indexes of refraction, which will make the light bend. Without that, if you have just a uniform spread of gas, regardless of what its index of refraction is, you wouldn't get that lensing effect.
Isn't that why we get blue light during the daytime?
No, we get blue light due to Rayleigh scattering, which is basically blue light has such a high frequency that it hits small particles of dust and water droplets and stuff like that, and gets scattered more easily than red light. Red light has such a large wavelength that it kind of goes in between and around those things.
So
Yeah,
there's
but
a
it has more of a chance to go around them than blue light. So,
So-
blue light
Yeah, and
gets
we're-
scattered in all of directions, and red light gets scattered last. When you there's an experiment that you can do if you take fine powder and mix it into water, and you shine a white flashlight into it, you can actually see the gradation of Rayleigh scattering, where the light at the bottom will be blue, and then it will gradually cross over into red at the top.
there's
I
another
got
really
you.
good. There's another
Go ahead.
really good experiment that you can do, which everyone here can do. If you take a TV remote control with the infrared on it, which normally you can't see visibly with your eyes, what you can do is you can shine that through a glass of water, which acts very similar to a prism, and you can then use an iPhone to pick that up, and you can see the difference between it if you shine it directly or if you shine it through that prism. Yeah, and it's quite a good experiment to do using red light. Try it. The water is enough to change the light, slow it down, and split it up a bit. Makes it very visible.
So back to what we were talking about. A light ray moving in a straight line outside of the atmosphere will move in a straight line. As it gets into the thinnest wisps of the atmosphere, 400 kilometers above the surface, right around where the ISS is, it will slowly start getting bent, red being bent most. As you get lower, it'll be bent more and more and more and more and more, and again, red being bent most. So from the edges of the planet, you will get like if you look at a cross section of the Earth, you will get two triangles from each end of the Earth, from each edge of the Earth, spreading out into the distance. Here on Earth, we see sunrise and sunsets when we are in those triangles, when that bent light hits us. That's why you see a red sunset. That's why the clouds above us are lit red during sunrise and sunset, but then we get a night which doesn't have that. ISS, when it orbits high enough that it gets prolonged sunrise and sunsets, right? And then it gets into the darkness. The moon is so far away that when during lunar eclipse, it is always in that scattered light. Does that answer your question?
It's a good response. Yeah, I don't know if it's
What the hell?
verified answer, right, Barney? But I respect your response and Toadie's.
It's like your that's ridiculous.
I would say that for what you're asking, yes, there is an area where if you take those triangles in cross section, right? It would be an inverted cone otherwise. If there is an area where that red light doesn't hit, where if you put an object there, it would be in full Earth shadow, which is even more than an umbra, right? Which is complete shadow, I guess.
Is refracting
Where
light-
it doesn't see sun at all, not even through the atmosphere.
red light is a very interesting thing, right? We have red shift. We got all sorts of measurements about this red light. Does red light diffuse faster than, I'll go to the extreme, white light or blue light, violet, green? So the diffusion of it, yes, let's say it refracts off the surface of the Earth, from the sun, Earth, to the moon. We're talking about the lunar eclipse. I get what you're saying, how the light comes off and just glances off and then turns into, white light turns into red light somehow. And then
So white
what
light
is the diffusion
white
of it?
light is a mix of different wavelengths of light. If you,
So-
on average, mix up all different lights, you will get white, right?
What about the
What prisms
diffusion of
do,
red
they
light?
just separate out those wavelengths, similar to Rayleigh scattering. What it does, it simply it removes blue, so what remains is red.
And so you know, Aaron, that they discovered another little bit of quick history from me. You know, they discovered infrared because he noticed a temperature change on a thermometer. So he was looking at the top and the bottom of the spectrum. So he had a prism. He used that. He split the light out into the component colors, and he happened to have a thermometer that was actually above the red bit, and he noticed the temperature change there. Yeah, which is what put him onto the fact that there was a light that he couldn't
measure
even
the
see.
temperature of light.
That's right. And he
I
saw
actually-
that there was a bit that he couldn't even see, but it changed the temperature. Sorry.
I preempted that just by walking into the sun and saying, "Wow, I feel hot." There was no red light. There was, Now, to measure that, Toady, if that's what you're saying, that somebody felt that, put out a thermometer and said, "Oh, wow, there must be a spectrum of heat that we cannot see," right? Like a fire or
Not
a red
visible,
hot thing, a red hot thing. Yeah, well, then definitely that's what science does. Awesome. Thank God.
That was Newton.
Oh, it was Newton. I don't remember who did it. Was it Newton? Fantastic.
Sure.
Yeah,
Was
he's a
Newton.
super genius then.
Has nothing to do with the refraction of light, though. Yeah. But definitely a very important part
It
of our
does,
life.
because that's how you discover which parts of light
Oh, it
carry which
absolutely does have to
temperatures
do
and-
with the fraction of light. That's what he was testing, right?
Heat, a thermometer.
Yes.
Did you not understand? He took a thermometer, so he had
So-
the prism,
A
the prism
prism.
that you were talking about earlier, and he put
So
the thermometer
thermal-
further up out of the
Thermal
light.
radiation. Thermal radiation. I can put a prism next to a oven burner, and because there's thermal radiation from that, I can get a rainbow from heat.
No, you take a prism and you take white light, and you split that white light into different colors, into the rainbow, right?
Yeah, I get
And
it.
then
Ron.
in that spectrum of colors, you put thermometers at each color. You put one for blue and one for green and one for red, right? And then you put one aside to measure the ambient temperature, something like that. And he had one which was standing next to the red one in what he thought was shadow. And that one measured the highest temperature.
What color is moonlight, Barney?
It's white.
No, there's no such
You
thing as
mean-
moonlight.
Okay.
Sorry to crush
Sorry,
your
moon
dreams again.
reflection. Sorry, moon reflection. What color is moon
He's
reflection?
trying to be an asshole again, Barney.
Yeah, I mean, I'm doing this experiment with Sleeping Warrior, but I did do it the other night. I couldn't
It
get any.
depends on where
heating
you're
effect.
looking at it from. But otherwise, it's white light. It reflects sunlight.
Sure. So the red light that was taken in this experiment, where he separated through a prism the colors of light, and he put a thermometer, up against all the colors, and found that the red one was the hottest. Is that what you're
No,
saying?
above
Or
red.
warmer?
Above red. No,
The one
above red.
above red, the invisible light that was above red.
Whoa! How do you measure invisible light? If
Exactly.
he
That's
was
the whole
using a
point.
single source, was he using a single source of light?
He was using sunlight.
Yes,
He was
the
using
sun.
sunlight from a mirror. He had a mirror, and he reflected it in a very small beam into his prism. He split it up into the component parts, and as Barney said, he
so
had a
we
thermometer.
would call that invisible light. We'd call it white light, right?
Infrared, actually, and that's why it's called
No,
infrared,
what
which means I think
was-
above.
It's white light, and then you split it through a prism into its component colors, right?
Yep.
Into
I get
things which make up that white light.
So if I take a mirror from the sun, and you're standing 50 yards away from me, I take a mirror and I point it at you, and I'm angling the sunlight, this white light, over to you, will you feel heat?
Yes.
Absolutely. Have you ever seen a Fresnel
So
lens? They can melt
that's
rocks with.
that's a reflection. And so what is moonlight? Or moon reflection, sorry. What is that?
It's a reflection. Yes.
And how can you explain it?
How can I explain what?
Temperature.
What temperature?
There have been multiple experiments done that moonlight is cooler than the shadows around, or sorry,
Bullshit.
yes, cooler
I call
than
bullshit.
the shadows around.
So So, Aaron, three things. I'm
Multiple
doing the
experiments.
experiment. Hang on. I'm doing the experiment with Sleeping Warrior to look at this. We've both just gone and bought these thermometers, not infrared thermometers because they have lots of inaccuracies. We've actually bought meat thermometers. We're going to do the experiment. I did do a trial run of it the other night. I couldn't find an effect yet, but I'm absolutely willing to try. There are lots of people who've debunked it. It's generally a bad method that people use. If you'd like me to point, if you want to point me to something you think is a good method where someone has done it properly, I'm willing to look at that. But all the ones that I've investigated have been quite poor method. So what typically people do, and I touched on this on my other channel. So what generally happens is people say this. They say, okay, I'm going to shade this thermometer by putting a box over it. And then this one that is open has the moonlight on it. Oh, look, it's colder. And what actually happens is by putting the box around the other one, they keep the residual heat in, and the one where the moonlight is naturally colder.
Yep,
And typically what happens...
The ground.
Yeah, and so that's it. So let me carry on. And psychologically what tends to happen is you will notice that you will think a moonlight night is much colder on your skin, when you're out in moonlight, because there's no cloud cover. So the fact you're seeing lots of moonlight also means there's no clouds around. Now, clouds keep the heat in. So generally, when it's moonlit and you see lots of moonlight around, you go, oh, it's cold.
You don't have to go that far. You asked me what experiment I would do or what I've seen.
Absolutely. Tell me.
Let's say you take a medium conductive material, right? You take two pieces of the exact same conductive material to ambient temperature. Let's say a plate. Porcelain, is that pretty good? I don't know, Barney.
Well, it won't conduct anything. A plate of porcelain will not conduct anything.
You put it on a stool over in the shade. You put it on a stool over in moonlight. You walk away for an hour. You come back and you take your flare gun and you measure the temps on it.
Right. So first of all, we don't want to use a flare.
Wind has nothing to do with it because they're both, both experiencing the same atmospheric conditions of, pressure, temperature, wind currents, all that stuff. It would only be the light, or narrowed down to be the light. Right?
So you're talking to someone who's done that. I took readings actually for 30 seconds every 5 minutes. Yeah, of those, one was resting in non-moonlight. I had a control, and then one that was resting in moonlight, and another one had the lens that Anthony thought would intensify the moonlight upon it. And my results so far have not been conclusive at all. I've noticed no effect. There is natural variations just based on the thermometer. And then what I did is I swapped the two thermometers over, by the way. I took the two thermometers and then I swapped them over. And the reason, by the way, for not using one of those infrared thermometers is they're notoriously inaccurate. Any shiny material will create problems when you're taking a measurement. I do have one of those, by the way, one of those infrared thermometers. They're just notoriously inaccurate. So I'm actually using, with Anthony, this is Riley Sleeping Warrior, who I'm sure you've heard of. We're using the same meat thermometers, which go down to, I think, minus 50 degrees C all the way up to plus 50 degrees C. So we've got reasonably accurate enough thermometers.
That's actually a good one, Toady. Why not just put thermometers out there? Why use plates
that's what we're using.
Guns and all that shit?
Yeah, I agree. Thermometers is very good, right? We've got these digital thermometers, which is what we're using. I agree. That's why we chose them. Anthony chose them, actually. And I agreed with him. They were good enough. And they'll measure down to 1/10 of a degree. Yeah.
Okay, so white light is not radiating heat, apparently.
Doesn't appear to be, but we're going to conclude the test. We've not both done the test. We want to both do it on the same night, by the way, from the same moon. We're doing the same test on the same night at the same time. Yeah, we've not done that yet, by the way. So don't think I'm saying that we've done that yet. I did a trial run.
When the sun comes out, it's noticeably cooler under a tree than it is out in the midday sun. Noticeably.
Yeah.
That's why we all hang out there, right?
Absolutely.
But yet the reflected white light from the sun off the moon to the earth, there is no change. So
there are super actually that's untrue. That's actually it's slightly untrue. There is actually technically, and I've not seen it, you need a very, very sensitive thermometer. There is actually a slight heat increase, apparently, I'm told by physicists, from the reflected light from the moon, right? But it's such a tiny amount, you'd need kind of a lab with a very sophisticated setup to actually measure the difference, right? But obviously it is reflecting light, so there is some element of heat in the light.
Okay, I have to ask Barney, just for clarification, of white light I know we separate it into colors, and we find white or invisible light is infrared. It, correct me if I'm wrong, Barney. It has heat carrying capabilities.
Every
How
light,
would you correct
so,
that? Yeah, how would you say?
okay, so every light carries energy. That energy is proportional to its frequency. And by frequency, I mean color, right? The
Mhm.
frequency of light is what we see as color. Every light carries energy. The higher the frequency, the higher the energy. Now,
Mhm.
what heat and temperature are kinetic motion of particles inside a material. Light does not carry heat. However, um, at certain temperatures, particles can emit light.
Be
And at
excited,
certain
right? They
temperatures,
get excited.
particles can absorb light. So particles can absorb light, turn it into kinetic energy, start moving faster, and therefore have more heat.
That's how we
Um,
see it,
the
right?
the spectra of how that light is absorbed or emitted is called blackbody radiation. If you take a perfectly black body, heat it up to that temperature, it will glow with that color of light, with that frequency. The thing that gets absorbed the most and causes most kinetic motion under the conditions that we usually measure these things is infrared light. And that's why we say that infrared light measures temperature. And when you take an infrared camera or the infrared temperature detector, that is literally what you're doing. You're filming the black body radiation of an object which is at around 20 degrees
Why
centigrade.
do you
And
have to
then
call
as
it
it
black
gets
body?
hotter, it gets into near
Because
infrared,
it's
and
just
then into red,
radiation,
and then
right?
into orange, and then into white, and then into blue. Sorry, then into blue, and then into white.
Barney, why do you have to call it black body when it is simply just radiation? It's a thermal radiation from the source. I get you. It has to hit something first and then radiate, right?
Yeah.
So if I have a white panel laying on the ground in front of me and the sun's beaming right up into my face on it, I don't feel too hot. But the black one, for some reason, I get near it, dude. It's just burning me up like a hot asphalt road. You know what I mean? Is
So
that what you mean? Black body radiation, where white light, infrared light hits a substance, and it may or may not absorb, or it reacts to the light, and emits its own heat, its own light, kind of.
So how colors work in general, right? You have a spectra of lights by their frequency. Some materials can absorb certain frequencies of light. So if you have something that absorbs a wide range of spectra but doesn't absorb green, such as, let's say, the chemical called chlorophyll, right?
Let's go
Chloroform,
with
chlorophyll,
physical
right?
materials like
Then, then,
roof
then,
panels.
then it will absorb all frequencies of light except for green, and it will reflect green. And
Let's
that's
go with
why
physical
all the
materials.
plants that use green chlorophyll look green, right?
How come?
They're absorbing everything else and emitting green. Now, what is color black? Black is the color that absorbs all frequencies of visible light.
My black sweatshirt, right?
Yeah. So if you have a white t-shirt, that white t-shirt will reflect all colors of light, whatever hits it, all colors of visible light.
Which is why
If you
it's
have a
super
black
visible
t-shirt,
far away, right?
if you have a black t-shirt, it will absorb all of those colors of light and turn them into kinetic energy of the particles. It will heat up,
Yeah, my
right?
black sweatshirt that I lay out in the sun versus my
Yeah.
white one
So
that I lay out in the
that's
sun.
why
When I go
that's
pick them
why
up, yeah,
that's
when I go
why
pick
if you
them up,
wear black on a very sunny day, you will get much hotter than if you wear white clothes, right?
yeah. You're
Now,
exactly right.
Interesting question on that, just very quickly, just as a little fun aside. I met this guy while I was doing my Egypt tour who wore black all the time, and he claimed that he'd got this idea from the Bedouins, and actually he was a lot cooler in the black. And my God, he sweated the whole time, and then he nearly got heat exhaustion. And this is in Egypt, right, where there's a lot of sunlight. Yeah, so I can absolutely say if you wear black in a lot of sun, you're going to have some significant problems. And he was an idiot, by the way. Sorry, Barney.
Yeah, but there are. Oh, didn't the Turks?
Bedouins actually
always wear black
do wear black robes.
Well,
Black
they do,
robes.
but is that not maybe for religious reasons or something?
I don't know
Bedouins?
why.
Yeah. Does seem
I
odd,
feel
doesn't
bad
it?
for those guys.
From the little I know of it, but this is way out of my area of I think it's something to do with like literally covering yourself up. Why it's black, I don't know, because they're not bleaching it or not.
So, Barney,
It's just a matter of the temperature doesn't bother them as much as sunburns, as being exposed to the sun, as losing moisture to the sun. So they cover
I'm
up
leading
the-
you to another question, Barney.
And so why are skin pigments then black? Surely that's the wrong colour to be if you're in a hot country. Surely white would be better to reflect the sunlight.
Because everything that we're talking about color deals with visible light, right? So that black T-shirt might be absorbing a lot of all of the other colors, but emitting a lot of infrared or just letting the infrared through. You don't know. That depends on the material.
Yes, it depends.
Now,
on the
the fact that skin is dark or light has nothing to do with color. It has to do with the property of absorbing or reflecting ultraviolet.
Ah, okay. Didn't know that.
Right.
Okay.
So the melanin is a protein which your skin produces
vitamin D.
when it's exposed to ultraviolet to protect it from the ultraviolet, to stop it from going deeper into the skin
from getting hot.
and reflecting it out. Not by temperature, right? And when you use sun creams, there are two different kinds of sun creams that you can use, which are either reflective or absorbent. Absorbent ones will heat you up, but will not let anything get to your skin. Reflective ones will reflect away. And it's really, really cool when you look at it through an ultraviolet camera, the difference between those two, because when you cover yourself up with one, you look metallic. You look almost like a mirror under the ultraviolet camera, and when you cover yourself up with the other, you look flat black.
It's the cloak, right, Barney?
Yeah.
The cloak. The infrared cloak.
I must go and try that. I've got one of those cameras. I'll go and try that. That'll be interesting. Okay. Cool.
Yeah.
Good idea.
So my sweatshirt, my black one, my white one that laid out in the sun, and pick them up. White one, no problem. Black one's like, god damn, like I just got out of the dryer. You know, it's hot as fuck.
Yeah. Because it absorbs all the frequencies of light and all of their energy.
Or car seats,
So
leather car seats that burn you.
Okay. Barney, I'm leading you.
In that respect, every form of light will heat up. So for your experiment, like if the experiment is not showing much in with the temperatures, coat them in black paint, or use duct tape and wrap them around.
Why didn't?
Because it will make them more sensitive to the light rather than ambient temperature.
On Earth, it was about 12 o'clock, 2 o'clock, direct sunlight, you could say. Why didn't my sweatshirt basically start to melt? Why didn't that happen?
Because it radiates excess energy away through infrared. That is the blackbody radiation. So that's the topic that we were on, right? When they were trying to figure this out, the thing that was bothering them is that they were doing it all by eye, and you couldn't detect light from A or B if it already has an innate color. What they were interested was what is the effect of temperature on light, right? So they came up with the idea of a perfect black body, a body which absorbs all light and only radiates away light through heat. And they tested it by using furnaces and just making a small hole into it, stuff like that.
Barney, right
So,
next to my sweatshirt.
as anything of any color or any type of material heats up due to its internal temperature, it will radiate away electromagnetic frequencies. It will radiate away light. If it's cold, it will radiate away infrared. As it gets hotter, it will move into near infrared, then into red, then into orange, right? So that black t-shirt that's been standing out all day has been absorbing all light until it heat up to the temperature where it started radiating away infrared light in the same proportion as it was getting in. So it will go up to a certain temperature, and then it will reach an equilibrium through blackbody radiation and remain at that temperature for the rest of the day instead of melting.
What if I took that sweatshirt, that same sweatshirt, and I got on a spaceship and it was hanging off the front of the spaceship, and I went towards the sun, right? Because the sun does not radiate heat, right? Just light.
Just light, yeah.
Yeah. So how close to the sun could I get with that sweatshirt before me or my spaceship and the sweatshirt melted? How close?
Let's find out.
It would be a surface calculation. So the energy of light from a point source, and in this instance, you can consider the sun a point source because it's radiating in all directions, is also
But it's just light.
inversely proportional to the square of the distance.
Right?
It is also inversely proportional to the square of the distance. And as you got closer and closer...
What do you mean? Radiation is proportional to the square of the distance
Yes.
of light? Infrared light?
Any light. If you have a point source of any kind of radiation. If you have a point light of any kind of radiation which is spreading out evenly in all directions, right? The intensity of that light when it reaches a certain point will be inversely proportional to the square of the distance.
Okay, so in order for that cotton sweatshirt to melt, I would only have to go half as not like a millionth of a closer to the sunlight, the infrared light, to get it to melt.
It depends on what your black sweatshirt is made of.
Cotton.
What its
Let's say
thermal.
cotton polyester.
I don't know what the thermal properties of cotton are, right?
Well,
but it would depend. Like if you had 10 different shirts, depending on what temperatures they could stand and what percentage of light they were actually really absorbing, because not even Vanta black is completely black. It still reflects some portion of the light, but yes, it would progressively reach that equilibrium of radiation closer and closer and closer to the sun at a higher and higher and higher temperature. So yes, ultimately it would melt and blah. But let's say you had a very thermally resistant material. Let's say you wove it out of carbon fiber, right? Then, as you got closer to the sun, it would slowly start glowing red and then orange and so on and so forth.
So carbon fiber tested on Earth here that they use for the Venus and Mercury orbiters, they test them here in proportion to the sun's heat, like you're saying. Is that how we test carbon fiber here on Earth?
Do we
to
test
send them towards the sun, right?
So most of the material, there is reflective cooling and there is radiative cooling. What the probe that's been going towards the sun has done is a combination of both. You have a very shiny surface so that it reflects most of the light instead of absorbing it. If you want to get even cooler than a white t-shirt, get a silver t-shirt, right? But whatever it absorbs, it is basically engineered that there is a combination of thermally conductive and thermally non-conductive materials so that the heat gets transferred around the probe to huge radiators, which are just large surfaces which are made to use that blackbody radiation to radiate away the excess heat.
And the solar panels powering that probe are also made of this reflective stuff?
The solar panels are angled and kept largely in shadow, right? They're at a very steep angle,
That makes sense.
and that angle changes as they get closer. And when you get close enough, basically the stray light from is enough to power the machine. Because again, same thing. As you get closer,
light.
you
What do
get
you mean
more
stray
and
light?
more and more power from that light.
What is
Again-
stray light, Barney?
Huh?
What is stray light? You said the stray light is enough to power, the machine.
The light
is
that
stray
gets
light?
diffracted around the thermal shield, and the light that gets shown by the corona, and right, that is not direct sunlight.
But light is infrared. It's not actually visible, So those panels.
Sunlight is very much visible light. It does have an infrared and ultraviolet in it, but I don't see what you mean. You've lost me somewhere.
So I've got a question. That sunlight that comes from the sun, it's only converted into some kind of energy when it hits something like the panels or whatever you said that are on the space system. The thing that's orbiting or going towards the sun. Is that right?
It is only converted into electric energy when it hits the solar panels.
The
Yes.
solar panels, or the heat energy when it has, so the sunlight has to hit something.
Fair enough.
Right. So what happens to the sunlight that doesn't hit anything? Does it eventually peter out somewhere? So think of all the sun that actually doesn't hit the Earth or doesn't hit the whatever stuff. What happens to that? Does it just keep going?
It just keeps going. Well, on galactic and intergalactic scales, it just keeps going. When you get to truly universal scales, you get into an interesting effect of space being expanded, which will redshift the light, which means that light will slowly lose energy.
But it does lose a lot of energy because when we look at it through our telescopes at the distant stars, it's just lost so much energy that there's only a little bit of visible light left. Is that right? We don't burn our eyes, do we? When we're looking at
that's the thing about so none of the photons that have reached you have lost any energy. It's just that a lot fewer photons have reached you, right? If the light is spreading out in every direction, and you're next to the light bubble, and you take a meter square surface area, a lot of that light from that light bulb will hit it. But when you move away, that same square will get a lot less direct sunlight, and that's the inverse square
part of it, right? I see. So when it's 100 miles around that light bulb, you can still see the light bulb, but very few of the photons are reaching you compared to how many in the meter square. Okay, I get it.
Right? Compared to the surface area, which can absorb that energy. So you can keep increasing your surface area and getting the same energy, but that's an inefficient way of
very inefficient,
So on anything that's even like normal scale, conceivable scale, yes, that's true. right? So it just falls. The amount of photons fall off as you get further away, simply due to them spreading out through space, due to the surface of a sphere around that source being larger and larger as you get further and further away.
So what was this theory which they came up with, that there was an advanced alien race who, for the needs of their energy, had just, as each civilization develops, it needs more and more energy, right? I believe, yeah, because energy is, you can turn that into useful things, right? Whatever it is, you can use the energy to make stuff, okay, essentially for your civilization. The idea, I'm sure you've heard this before, of these suns, I've forgotten what they're called, and they have these rings around them where actually they're absorbing most of the energy coming from the sun because they need that much energy. And so apparently we might have been able to see them at a long distance because it like the sun went on and off a bit. Do you see what I mean? Like these rings were. Have you heard about this one?
So
what I'm talking about was it just
there is a classification of civilizations, right?
Mm-hmm.
At which level a civilization would be based on its utilization of energy.
Hey, Barney,
So
I gotta
it
go.
becomes level 1 when it utilizes all of the energy available on its planet and from its planet.
Barney, I gotta
without
go. I just want to say thank you. It's really nice talking to you, you and Toady. Thanks, Sean. Panel. It's been fun.
Thanks. It was
Maybe
a
next
pleasant conversation. Nice talking to you.
It was.
Take it easy, Aaron.
Well, Aaron, so thank you. I do appreciate it. Have a good one, sir.
I know, it was a good conversation. It was interesting.
This was a good conversation.
You bet, Sean. Thanks, Barney. Thanks, Toady.
Cheers. Just tell me about these. So level 1 is where we're at, pretty much.
So there are 3 classes. I forget what the name is before them. There is something class 1, something class 2 civilization. But if you Google class 1 civilization, you will find exactly what I'm talking about. 1 utilizes all of the energy of its planet. Second level, 1 above that, utilizes all of the energy of its star or its solar system, right? And a mathematician, what's his name? Came up with the concept of his name sphere, and I forget.
That's the one I'm thinking about. Yeah, exactly. Yeah. Look it up. What is he called? It's a brilliant thing, isn't it? Because, like I say, it absorbs all the light, and they thought they found this maybe these suns that were going on and off a bit, but they thought it was another reason.
What he described was a solid shell around the star, which then captures every photon of light that star emits. However, that is gravitationally impossible. There is no material physically possible which could withstand that configuration. It would necessarily be either ripped apart or crumble in on itself, regardless of how thick you made it. So that's an impossibility. Another possibility, under certain configurations, you can construct rings around a star, where you make a ring, spin it. Yeah. Dyson, thank you.
Dyson. It's called a Dyson sphere. Dyson sphere. That's
Dyson sphere. Then you have Dyson rings, and Larry Niven wrote a series of SF books which are really good to read.
No, they're fantastic. Yeah, Ringworld. Yeah.
Ringworld. Yeah, which are Dyson rings, but even that kind of requires materials which are physically possible, but we don't know of any that can do that, right. And it could be ridiculous and preponderant. But there is a way that we could do it using basically our existing technology, if we put in enough time and resources to it, and just used up everything in the solar system, which is a Dyson swarm, which is basically a Dyson sphere or a Dyson ring of objects which themselves are small enough not to undergo tidal stresses of being that large. They're plates, basically, like you can imagine having a satellite spread out its solar detectors, right? And put it into orbit of a sun, and then just continue doing that until you engulf the whole sun so thick with satellites that nothing escapes. and that's called the Dyson Swarm. So when they found this star, which had a very uncharacteristic dip
That's
in
it.
light,
Yep.
right? So the Kepler Observatory finds exoplanets by measuring when the planet traverses the face of the sun. So it can only find the planets which are in the same plane as we're looking. When the planet traverses, you can measure a tiny decrease in the brightness of that star. And if that decrease has a certain shape, you can say that it's a planet. And based on how long that dip is, you can find out what the orbital speed of that thing is. Therefore, you can find out how far away it is in orbit if you can estimate the size of the sun. From how much it darkens the sun, you can find out how dense it is. Is it gas giant or a rocky planet or whatever? And that's how we discover planets. So there was this dip in data, which was very uncharacteristic and very irregular, and didn't. Oh, and from how often it repeats, you can find out how long its year is. So you can confirm its mass and radius and all of that from that. So this was a very uncharacteristic dip in that it was irregular and it didn't repeat itself and had various artifacts which were unexplainable. So it could have been a cloud of rocks or ruins of a planet or something like that. But one of the possible explanations was that it was a Dyson swarm in the making.
If anyone's interested, I would absolutely say Google Dyson sphere and read about that planet you're talking about, because actually it's really interesting. It's called Tabitha Star, isn't it? The one that you're talking about.
Yeah.
So the Kepler Space Telescope found it, and basically, long story short, they hypothesized, as you said, all these explanations that maybe it was loads of comets, maybe it was lots of different things, but they've come back really researching the alien hypothesis. Yeah, that it was perhaps a Dyson sphere in the making, because it got very regular dips in its intensity. Yeah, it kind of goes on and off very, very regularly. Yeah, which is quite odd, they're saying. It's a really interesting bit that I'm reading. Yeah, fascinating. Look it up. Really interesting if you're interested in aliens and that kind of thing. It's certainly an anomaly.
I'm going to say that aliens aren't real because subconsciously my brain is scared that there is. There you go.
And it's
So
safer
you're
to
just
think
not
that they
willing
don't
to
exist.
admit it.
Oh, I'm never going to admit that until one of those fuckers are in front of me and I'm opening the hatch and I'm punching them like Will Smith.
Welcome
What if
to
he's
Earth,
like smoking a
motherfucker.
cigarette?
Exactly.
What if he's like smoking a cigarette in front of you? You know, looks like a regular human. You know, what if it's like that? Maybe they're already among you.
Then I hope that little zapper thing that they zap people's brains with, I hope it works. And I hope it doesn't fry my brain every time I've seen something and they've zapped me. And it's better off we don't even know.
What if they come and say, hey, we've been watching your channel on YouTube and we're huge fans and we want to join the Truth Army?
Do you guys smoke?
Hit the like and subscribe, and we'll talk with you in a little bit.
I'll leave for another time my alien artifact that I recovered. That's a good story. It's one of my, I've got two alien stories. One isn't really, well, it is. It's a UFO sighting, but there's an explanation for it. And the other is an alien artifact. But I'll leave that for another time because I've got to run. Unfortunately, it's quite late here in the UK.
Thank you, sir. I do appreciate it.
Yeah, I'll be on my way as well. It's 2 a.m. here, and I'm in the middle of the street because I don't want to wake people in my house, and I'm cold, and my back hurt, and I want to go home.
Yeah, no worries, no worries.
Right.
Like I said,
It's been a good conversation, guys.
yes, I do appreciate both
thanks,
of you guys. That conversation you guys are having, this is a good one.
That was good.
Actually,
Aaron was quite interesting. Yeah.
Those
Good
are
questions,
actually
both of
the
them.
ones I go back into and I listen to like a couple times because I want to get the information. That was good. But totally,
Yep, exactly. I'll be listening to this later on again.
Yep. Totally, I didn't know that was your profession. We have a lot of things to talk about.
Yeah, I mean, it was.
Okay.
It isn't
No,
now. I've gone more into management, but yeah, I spent many years, many years working in mapping. Yeah, I mean, I
Awesome.
love maps anyway, right? And I always did, and that's why obviously, career-wise, got into it. As I say, if you watch the video on my channel, it's a lot about me there as well, and about how I went from mapping to telecoms to satellites, back to mapping to smartphones. It's all there. Yeah. Yeah. All right. Cheers, guys. Really nice speaking to you. Bye.
Thank you, sir.
Bye.
See you, Ted.
Thanks to everybody in live chat who said Dyson Sphere. I had a complete brain fart there. I couldn't remember the name. I just noticed that 6 different people came up to say what it was.
Oh, okay. So here's the new one that I'm now going to jump in. I'm starting a topic, but I'm very much so winding down to end. So in our chat, our buddy Gleam is here, and I've kind of noticed, like, to tell you the truth, Gleam was actually the reason I did this stream, because he had made that comment last stream, Sean, and he had said something about the flat Earth, like flat Earth. What was it? I have to look on my site. Damn it, I don't remember. He said something about flat Earth maps, but or simulators saying it was flat Earth. That's what it was, and I wanted to. I said something earlier about it, so I said something about it, but he wasn't here, I don't think. But he's now here, and I watched one of the videos he was talking about, and it was flat Earth flights, Johannesburg to I think it said Sydney. It was, I don't remember. Pretty sure it was, but he depicted one flight. I gotta go to it again. I don't know what the hell it was. He depicted one flight that a jet airliner had made 700 miles an hour, or 700 plus miles an hour, I think. God damn it! Hang on, my OBS just hijacked it. Let me see. I'm about to show it right now, Brian. Or I'm not going to show it, but I will definitely show the problems I have. I'm trying to find where I had the link in here. Which one was it? But I mean, everything about it was wrong. That's all I know. And it was so wrong, I was able to identify it immediately, and then he basically just said I was wrong again and didn't get it. But I want to show it before I talk about it, because then it will make more sense to what I'm saying. And I don't know
I might not have seen which one you're talking about.
No, I was actually just showing it. I showed it on screen earlier, but it was you guys were in the middle of the conversation, so you guys weren't. I don't think you were watching the screen. I just saw it a second ago. I just don't know where it is. But I timestamped it and everything and put it in here. I can't find it. Give me a second. It's just everything about it irritated me. All right. Okay, here it is. I'll show it right now. I'll share it. You guys can see it. Like, it's just everything about it just frustrated me. So this video, the author or the creator of this upload is now stating that, or he's making a claim that the jet streams don't work the way we say they work. I don't even want to play it. It's so irritating here. And in that, he says the jet streams work like this, where it's like this swirling, like a top, then it gets smaller as it goes. And everything about that just irritated me.
Yep, automatically I can say that is definitely false.
Yeah, and so what I did was, you guys were having a conversation, so you probably didn't see this part, but what happened is I told them, I don't even think they can see it. Hang on. There you go. I'll make it big one more time for you guys in the chat so you guys can see it now. But I have other ones I wanted to show. So that's what the claim is. And then I showed him. Oh, this is his damn link. I'll do that one after. I just found like a random image of the jet stream. Just a random one. I'll just find another one. Actually, it was one of these. But it was a little later in the year. I showed him this one. And he said, he came back and told me, gave me this article, which is another flight that flew like a high rate of speed. And I'm reading this article, and I come to realize that like he gives it to me because he says that it's talking about the jet stream and climate change. But again, it's not saying that the jet stream will become some completely different type of stream. It's going to be the same. It's just going to be stronger and weaker in certain areas, and it's going to move differently. But it's still going to be a stream that goes around the world. Doesn't change like that. It's impossible. Man, it's crazy. If that were the case, pilots would have to navigate through what? I think it was like what, 3? 1, 2, so 3 different streams going completely opposite direction. It would rip planes apart. Come on, Clean, you're way smarter than that.
Yeah, it would. It would completely. I mean, you would never be able to reach where you want to go with those jet streams. You would have to make a circular pattern. You'd have to make a circular pattern every time, and you could never get back to the center.
You'd have to. But you'd have to go around. You'd have to go around the world 3 times if you were in Africa or Australia to get to anywhere in the northern hemisphere.
Yeah, but you would never be able to get back to the center because the wind would be totally against you. If you were flying from the outside, there's a jet stream that's in the middle that completely stops you from going into the center. If you follow the arrows, you would never cross over those 2 sets of jet streams because you'd be flying with one and then flying into another. It'd be like flying into a wall almost.
Yeah, every time. Like it'd be like every time someone would go on a flight, they would literally be like, "We may never see you again." I know. Flights would be $1. Trust me, no, those flights are impossible. No.
Yeah, think about back in the days when they had like wooden frame airplanes and stuff like that flying around the world. A Zeppelin that flew from Germany to U.S.
Jesus. And Glenn, you're so much smarter than that, man. Don't do that. So much smarter than that. That's impossible. Impossible. You just showed me some fiction. Oh, then he says, "Pull this up, I dare ya." If you give me a virus, man, that's fucked up. I thought we were friends. Have you lost your fucking mind? Those are separate jet streams. What is wrong with you? Why is he on drugs? You just showed me a jet stream in the northern and southern hemisphere. Okay. But where does that swirly shit happen? Where does the misdirection happen? And why are you showing me these jet streams if that's not even what you think is going on?
It looks like he's just trying to throw a whole bunch of stuff at you, just to see if you look at it.
It's not working. And also, Gleam, the projection that you showed me, the model that you showed me, fits on the globe. Sorry, buddy. See how that Pac-Man shit happens? That happens for a fucking reason. Because it goes back around to itself. Bring it. Come on, Gleam, bring it. I think I want to debate Gleam. That'd be fun.
You don't even need a moderator.
No,
You two would
hell
just
no.
sit there and, you know,
Just BS
have
the
a
whole time.
conversation.
You would be there for the moderator, though. Just so everyone understands what I'm doing, I'm voting for Sean Smith to be moderator every debate. I'd like you all to vote for him too, or vote with me for him too. There you go, got it. I know you didn't even
Oh,
to or
God.
anything, but yeah, I just decided because I listened to last night's hangout after the stream. I don't know how the hell you sat through that. Sean Smith here sat through Gleam and Channel X duking it out. I like how they and them came around and was like, "Hey, shut up! You guys sound like little girls." It was great. It was awesome. It wasn't even. And here's the thing, they're both foreign to me, right? So what ended up happening is it just sounds like two kind of aggressive guys talking, but not trying to be mean to each other. It was weird. It was entertaining and disgusting at the same time.
Yeah, it was like Barney and Montreal when they were debating.
Yeah. Yeah, like you were waiting for the jab, but then they just, pat each other on the back and then keep going.
No, sir, I respectfully decline that.
Yeah, it was funny. Which one? Yeah, I trying to think. I think I'm gonna play because it's only like maybe a half hour, 45 minutes, maybe tops. But the recording kept going, so I got like 3 hours of it to go through, and then I got to go cut it up. But yeah, I'm gonna play it because it was like a perfect example of like you think you know, but you have no idea, and then like you are wrong, but then you have no idea. Like Gleam and Channel X are like the most eccentric people on here. It's like they're here, like they come at you like one reason, but they're here for another reason. But you could never get to the other reason with the reason they use. Like Channel X wants to ask questions, but he can't ask questions. He has to attack every time. And Gleam,
Yeah.
Gleam,
And they and them called him out for it too.
yeah. Ask
yeah.
Channel. I don't know why he didn't say something then, but I've been calling him out since before he became Channel X. I literally, it was like when he first came into this community, I was like, dude, I had pulled him aside and I was like, dude, you can't do that. Like, you want to talk to flat earthers, there's no way in hell you're going to be able to talk to him like you do. And he used to calm down. Now he's back at that attack mode again. If he comes on or next time I see him, he'll admit it. He knows. I know it's bad. He's like one of the worst. Like he's not an asshole. He's not disrespecting. He just attacks too bad. Like it's bad, and that's his problem.
Well, his problem is he thinks in his opinion science proves stuff. That's his whole thing. Science proves this. We know this. We know this because of science, and you, me, Barney, all of us will tell you, no, it's to the best of our knowledge. That's as far as we've gotten. Now, it's not. I'm not saying that it's never 100%. There's always going to be a 1%. But when the evidence is 99%, it's pretty much 100%.
Yeah, it's bad because then there's Gleam, who will fight you tooth and nail for that flat Earth, right? And then I think what his bail on it is, I'm not a flat earther.
Yeah, exactly. He just wants to bring that 1% out into the open. That's all it is. Now, did you watch Jose's show this morning?
I did not.
Oh man. So Allie B, Rumpus, there was a whole bunch. Blue, there was a whole bunch of us on there. But first, Jose called out flat Earth. He said, just bring evidence of flat Earth. Bring a model. That's all you have to do. And he didn't want anybody in the panel except for the flat earther to bring any sort of a model. And Ali B came in with a uh, uh, attitude meter for flying. So, of course, Blue came into the panel and then Dr. Bob and everything like that, and it just started going downhill afterwards. Because Ali won't back down, and then he starts over talking, and then he whines to Jose a little bit, and then it just after a little while he just started calling names and everything like that. He was calling everybody names, and then did a big personal attack on Channel Q, and but he was calling everybody names.
Oh, okay. So he just went militant for no reason because I saw his live stream right before I went on, and I was like, "Hey, what's up?" And he's like, "F you this, you're this for what you did to Travis." I'm like, "Are you? Wow, okay." That's why when I started the show, I said, "F you, Ali B."
Yeah, and here's me, like, can we just get back to the topic? Can we get back to the topic? And he's like, F you, you're a effing dick, and blah, blah, blah. And, and I'm like,
well, here's the thing.
Allie, I've been nothing but respectful towards you, but, you can hate me if you want. I don't care. Yeah.
Well, then, Travis and Ali B will never go on anybody else's show ever again because what Travis was upset at for me for was Erebus. But when it came down to his anger, he blamed me for it and saying I planned that and I had tricked him onto my fucking panel. And so I unsubbed, I fucking unsummed it and fuck him, whatever. Then, like I said, I go on to Ali B's stream and all of a sudden he's like, fuck you this, fuck you that. And then he blocked me. So I'm like, oh, okay, cool. If that's anyone who watched those, and I'm only talking to flat earthers right now. Let me know how many of you thought I was disrespectful at all to Travis, and how I came through. I went through his fucking his observations, and because I did it with like on a fine tooth, he's pissed. That's why Travis got all upset. I showed him that he was wrong in something. You know what that does? It makes him butthurt. And that just makes him see if he's going to be butthurt that he was wrong. That's not a truther. That goes to Ali B and Travis. If you're upset because the information was actually wrong, you're not a fucking real truther.
Well, and the other thing is you told Travis, you said, we got some problems. Yeah. It wasn't, and you said, one of these days, I've got something for you. And then you told him before he came on the panel that day, if I remember correctly.
Oh, yeah.
Guess what?
Yeah. Huh? and so this is what I'm going to do. I'm literally going to go through all my live streams for the past week and a half, 2 weeks, and I'm going to cut up every time I said something about your ether band, Travis, so anyone can relay that to him. I don't care. Like, the fact that's what pisses me off the most. Like, I say a lot of things piss me off, but here's one thing that really pisses me off. When you act like I'm a disrespectful person to any flat earther, I actually jump down people's throat that are globers faster than I will any other flat earther for how they're talking or being in my chat or on my panel. Now, if you're upset because I say what they're saying is wrong and I show evidence for it, think about why you're upset then. Think about why you think that way. What's up?
Yeah, and hey, Brian.
Oh, not much. Sorry, I had a hot mic, so I was just muted for a second.
Yeah, I watched. Miles Davis was on Travis's show this morning as well. And Travis tried to play it off as he knew more than Miles Davis about pictures and things like that. And
Isn't Miles a photographer?
Miles has he's a biologist, I think, but he's been taking pictures for, I don't know, freaking 40 years or something like that. And and if you look at some of his pictures, they're absolutely amazing. You know, so I don't know, but he the way he was talking to Miles was like, well, my suggestion to you would be, and and just the tone, and I'm like, oh, that's just terrible. I don't know.
Travis has a lot of condescension in his voice for someone who, by his own demonstration, knows next to nothing.
Well, and I think it's the fact that when he started up doing the live streaming or something like that, maybe that went to his head or something. I don't know.
Sorry, I've got to be taken aback by something I just read in chat. Matrix finally got back to me. He told me that engineering is not science. I don't know how to understand that.
No.
Yeah, hey, Hannah, I'm not going to watch it, but let Travis know I said a big fuck you. Because they know it. And that's some bullshit. That's irritating. I'm triggered right now. Serious. That shit irritates the fuck out of me. Like, you go out through, like, it's not even, I make sure I keep it respectful. Like, I keep my panels respectful. If you can point out one time where I was like, Erebus was being an asshole, and I was like, yeah, get him! Like, fuck that.
No, you even told Erebus, you were like, Erebus, knock it off.
Yeah, he told Erebus several times not to call Travis a liar. Just when Travis finally became apparent that he was lying, he took it as a cue to leave.
Yeah,
and Matrix, I guess I should qualify that in saying that engineers necessarily use scientific principles in order to perform their duties.
Yeah, it's disingenuous to me, and I like it when people act as if I was different. Because guys, it's all recorded.
Yep.
I mean, he could always take the LAB route and just assume that he's never been at fault once, and if he listens back, he'll always be the victim, not the perpetrator. That's just what Ali did today. He came on to say, "Listen, I've gone back and listened to every spot I've been on, and I've never been the aggressor," which is ludicrous. Ali comes in hot and says awful things to people.
That's why him and Pete were on here for a while, and they just disappeared because I got pissed off at them for it.
Well, that was the very first thing he came in. Oh, but everybody talks over me. He was the only one in the panel. He was the only one.
Everyone. That's his MO.
Yeah, but that was the thing. He was the only one in there, and he's like, oh, Jose, you're gonna have Globers come in here. They're gonna talk all over me and blah 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 blah. And, and automatically you're setting a precedence for what's gonna happen.
Yeah, that's the thing. It's like, it's like it doesn't work anymore. Like before, that was like a real good argument. I get on there and the ballers, they all attacked me and they ganged up on me. It's like 5-on-6 and 6-on-8. And it's like, well, there are platforms now where you can make it fair. You can make it so it's even. Or shit, there are platforms that will let you go on by yourself. And they're not doing it. And then when they are in a situation where it's not disrespectful and they get stuck behind, like in that corner, they need something. And now I guess it's just saying someone was disrespectful. But all you're doing is irritating the one person or not the one person, but someone who isn't disrespectful. And stomping on the platform that you could be on and be respected at. Now,
yeah, I think Ali thinks he's asking rhetorical questions when he asks questions, because the moment people try to respond to him, the first thing he does is tell them that they're interrupting him.
Yeah, he's a special one, and you know what? And I didn't even care because Ali B is Ali B, but if he's gonna jump behind this ether band, aka atmospheric conditions, then hey. Tell them to bring it because I used some of that Anacapa Island stuff that I had from everything that was going on to show kind of like exactly how topo maps work, and then I did realize, hey, why don't you show this? And I think I will right now actually. I showed exactly how Erebus's depiction of how that worked. How you overlaid those two pictures.
Mhm.
Yeah, well, that was like the main thing they called foul on, and it was like, wait, how do you call foul on that? And so what I did is I kind of did I showed you guys I was starting that topo map stuff, and in doing so, I also did a profile because that was the other issue. They kept saying the profile was off, and I wanted to show them exactly how we know the profile wasn't. And I gotta find the picture. Hang on. Have it.
I sent that to Rumpus.
I don't remember where I put it. I think it's in
That would be cool to do a video. Let's see, you can't do a picture overlay to prove a point because you can. It's very easy to proof of concept that you can go to your kitchen, move the table away, take a picture of a chair, move the table back, take a picture again, overlay the pictures, and it works beautifully. You can see how much of the table would be, how much you can see the chair in exact proportion according to the table.
I'm gonna put it up on this. Okay, hang on. I'm there. Hang on. La la la. Yeah, I even have it in here already. Damn, there's a lot of fucking pictures. I gotta like do like a spring cleaning on my OBS now.
So at one point, Travis was bringing up the ether band, and I said, I said, okay, Travis, if we take a balloon at 117,000 miles up, we have all of the data that you need. We tell you what lens we're using. We tell you exactly how to make the predictions for any curvature that could be attributed to that lens. Would you accept that? And he was like, I don't know, I'm not sure yet. I said, okay, Blue, let's pull up that video that we saw of that guy that sent the balloon up with, where he went through all of the cameras that he was using, what he was using for his balloon, including, this guy went into he went into way too much detail almost. It was probably like 3 hours or something like that. But you know, but he showed the cameras. He told them exactly what lenses. He showed the height. Uh, he used hydrogen in his balloon. He showed what balloon he was using, where he picked it up, all the information. And the balloon goes up 117 feet, 117,000 feet in the air, and you're looking at it. Oh, look, curvature. I said, so where's the ether band in this, Travis?
Yeah. So you guys can see the picture I have up on the screen right now.
Yep.
That's the Anacap line. This is just like this is a profile, and when I was doing the profile, I was like, oh yeah, I forgot to do this, this, and this. Then I remember how I was doing my topo, and I went, you can't. That is so 100% exactly how you would overlay something, because it all matches up perfectly. Even the fact that one of those pictures that he wanted us to do it with, it was like all the looming on it and shit. It was like the profile doesn't change, so it can get blurry, it can get distorted, but the tip of that mountain is never going to look like the bottom of at the top of that cliff. They're never going to have the same profile. They're not going to look the same at any distortion. So it showed me he's being disingenuous. It's really bad. So anyone else that jumping on the Travis ether bandwagon, you're either disingenuous or you haven't seen this stuff yet. That's a realization of what it is. It's bad. It's irritating the shit out of me right now, to tell you the truth. Like, it was like one thing that they were upset, but now it's like they're on this whole Sean's an asshole thing, and it's like, All right, cool. Just be mad. It's just a win. I know why. It's okay, guys. Change your manginas.
Well, I mean, I think you pretty much proved it when you were doing it live, and you pulled up his picture and you pulled up that profile.
Yep.
And you're like, oh wait, here you go. That looks pretty. Oh, that matches up perfectly.
And that was exactly when he went from discussion to that rage quit meter started climbing, and then all of a sudden he just left. And I knew why he left. Erebus was being an asshole to him, and I said something to Erebus. And next thing I know, I went over to Travis's, and he was talking shit. So
the thing about Erebus, if he perceives that you're intentionally being dishonest with him,
he ramps
he'll say exactly what he thinks.
Oh yeah,
and he thought he was being lied to, so of course he yelled out liar.
I like Erebus a lot, because what happens is that's exactly what it is. He said that in private. He's told me this. Yeah, the second I feel like they're being disingenuous, I just want to ramp it up until they admit they're lying. He does it because he saw something, and everything that he saw, just so everyone understands, every claim that Erebus had for Travis, he sent things to me prior to saying it live. So it wasn't like he was just making these blanket claims. I mean, all the pictures that he sent me that showed all this stuff, that's what it is. The difference is that I wasn't going to go, I got all this information from Erebus. Let me just... No, I didn't understand what Erebus was trying to show me. Every time you guys saw it, it was me pulling it up and Erebus being able to talk about it, and then it made sense to what he was doing, and that's when I started realizing where my brain was at, and then started changing how I saw a lot of the stuff that I was seeing as well. Because a lot of those images, there's one thing that Erebus didn't even say, but should have been said, and I thought he was going to. A lot of those images that are videos and images that we're getting from Travis, you should notice that they look like they're kind of aiming up a little bit. Just kind of like up a little, like just a tad. Like maybe if they're super low on the ground or to the ground. That's all I'm saying. But Travis, I ain't gonna go that way. That's not my problem. Travis has to be honest with himself. But yeah, I'm gonna get out of here, guys. I'm hungry. I'm so hungry. So hungry.
I gotta go to the gym anyway.
I got the munchies. Oh, munchies. All right. I'll be live tomorrow. Probably a little bit later on, or around this time, but tomorrow. And I think I have a fun one. We'll see. I have an idea. I'm gonna message a few of you guys in the Discord. All right. Anybody got anything they want to say? I mean,
no, not this time.
All right, Sean.
Eat your bacon.
Thank you. And that's it, sir. Thank you, guys. I'm gonna go ahead and end this out. Nope. Sorry, Matrix. We are done. If I let you in here, then I will continue talking, and then we have a problem. Bring it on tomorrow, or I'll see you around, and we can discuss it there. Either way, thank you guys. I'm hungry. I gotta get out of here. Luckily, no one had anything to say, so I didn't have anything to rant on. I ranted on already, so thank you guys. I appreciate it. Yeah, that's about it. Thank you.
You say you don't gotta go home, but you can't stay